Okay, here we are. It's Saturday night instead of Sunday night, so we've changed the day of the show for a couple of reasons. One is because um, Lawrence is not going to be available tomorrow night, and we understand that Saturday night's a better ratings night for YouTube videos, so we'll see if live shows, so we'll see if that helps, and we'll go from there. How are you, Lawrence?
Yeah, I'm just fine, Laurie. Yeah, I'm fine. I'm actually awake today, you know.
You are? Well,
It's
good.
still daylight here, which makes a difference, you know.
I can't get comfortable in my chair for some reason. Okay, so we have a really big shoe planned for today, and we're going to try to mess your mind up a little bit. As flat earthers, you're supposed to have open minds. You're supposed to keep your mind open because there is no, as we determined, there is no definitive map, no definitive model. We only have speculation and theories. We have Lawrence and I and some others have investigated the diamond-shaped map for months on end to see if we can find any serious flaws in it, and so far we have not. Also, so far, no one has debunked the diamond-shaped map, so it stands until that happens. Also, we feel confident that we have debunked the AE map, and it is not anything we set out to do. What we set out to do was to test the AE map for its ability to stand up to observable facts and to be able to agree with all of the things that are used to make up the globe. And so it has been checked, cross-checked, and beat to death. And we have determined, our camp, if you want to call it that, has determined that the AE map is no longer acceptable to be called the flat Earth map or the flat Earth model based on the AE map with the circling sun and circling moon and ice wall and dome plopped over the top. So if you are still open-minded and have not fully been indoctrinated into the flat Earth theory of this, based on this AE map and model, given to us kindly by the old guy back in the day called Samuel Burley Robotham. The reason why we checked it was because it was accepted as dogma. And once you accept something, if you do that blindly without verifying it, then you are officially considered in a cult, as far as I'm concerned, and as far as definition is concerned, because many religions and statist concepts, technocracies, are all based on dogma. And so here we go with another test, another question of what has become accepted in the flat Earth community and the flat Earth movement, if you want to call it that. And that is curvature calculation formula. And most people who have been in flat Earth for even a little while can rattle off the flat Earth curvature formula of 8 inches times the miles squared. So that would equate to 4 miles times 4 squared, that's the squared part, times 8 inches per mile. And so this will give you what would be considered the expected curvature if we lived on a globe 25,000 miles in circumference. So everyone who has accepted this number has done so because several mathematicians, engineers, people who know how to run CAD on computers have determined that that's the number, that's the magic number. Now, Globers will argue with you and say, no, it's just 8 inches a mile. Well, we all know that 8 inches a mile would be a slope. That's all it would be. It would not be spherical curvature. Spherical trigonometry, you have to square the miles. So here we are. Lawrence is going to present his answer to the question, is the curvature calculation formula correct for everywhere on the globe if we lived on a globe? And that's the question that has to remain in the background no matter what, because we don't live on a globe. But if we did live on a globe, this would be what you would expect to see with your own eyes, depending on where you lived. Did I do okay with that, Lawrence?
That was pretty good, Laurie, yeah. Are we ready to go rock and roll with this one now?
Yes, let's go.
Okay.
Lawrence has his lab coat on and he has his whiteboard, and he is going to be Professor Lawrence for the purpose of this curvature explanation.
All right, I don't know whether you can see the board. I've put on here the globe dimensions. Okay. These aren't really things you can argue with. These are official figures, and everybody in Flat Earth, when they're making comparisons between the globe and the Flat Earth, these are the figures you have. So you've got the circumference of the Earth, that's the distance once round, 24,901 miles. And for the purpose of this exercise, we're going to look at half the circumference, which is from the North Pole all the way around the edge to the South Pole, along the edge of the Earth. The radius of the Earth is the bit from the middle to the top in any direction. So from the centre of the Earth to anywhere on the surface, that distance is 3,959 miles. And if you made a little tunnel that went from the North Pole straight through the middle, down to the bottom, that is the diameter of the Earth. That's the shortest route from the top to the bottom. Okay, so what I'm going to do is to try and make this simple, because some people can't conceptualize this in their head. So this is what I'm going to do. So Laurie, you're on the top now. I'm going to do I can't draw as well as you. Drawing's not my forte. Maybe you could draw something more realistic. But you're stood on the top here. Okay, that's you. Yeah.
Okay.
That's
Boy,
Laurie.
I'm really big, but okay.
I can't do this to scale. And you've got your little friend with you. Who might your little friend be?
My little friend would be Jimmy.
Jimmy. All right, so Laurie and Jimmy. Okay. They're both stood on the top of the North Pole. Now, Laurie's going to be very brave, and she's going to jump down this tunnel and slide down it. She might have to break her fall once in a while so she doesn't go too fast. And she's going to slide down all the way down to the bottom, and she'll end up there. And Jim's going the long way. Jim's going all over the surface of the Earth, but he's got some very high-tech technology, probably, military grade, so he can take a perfectly straight line over this curve, and he's going to meet Laurie down at the bottom. All right? So if they do that, Laurie, you're going to drop just short of 8,000 miles, and Jim, because he's going over the surface, he's got further to go, and he's going to do 12,450 miles. So at the bottom, you've dropped 7,918 miles, and Jim has, but he's travelled further. So what we want to work out is how far Jim drops on average per mile on his journey to the bottom of the Earth to meet up with you. So the figure for that is your diameter, 7,918, and you divide that by the circumference, 12,450, and that gives you a figure of 0.6359 miles per mile. Jim's going to fall, on average, on his 12,450 mile journey, every mile on average he's going to drop 0.6359 miles. Obviously, at the start, it's not going to be that much, but it will get progressively more. And when it gets towards the equator and dropping down there, you know, it'll be falling hand over fist. You know, at one point, it'll be dropping a mile for every mile travel when it gets to the equator. So what does that work out in feet? Well, you multiply 0.6359 by 5280, yeah, which is the number of feet in a mile, and that gives you a figure of 3,358 feet per mile fall. That's how much you're going to go down in elevation. Okay, so that should immediately set some alarm bells ringing when you're looking at these 8 inches per mile squared. You look at the one that they've done on Chicago and the Bedford level experiment, and they're only showing small numbers. And we've got 3,000 feet, 3,358 average fall per mile. Okay, so let's do a comparison here with the Bedford level experiment. Can't see me there. With the Bedford level experiment. So the Bedford level experiment is in the UK and it's about latitude 50. So it's somewhere around about there, okay, on the globe. So they're well into the higher levels of curvature there. Not the highest, but certainly a lot more curvature or fall in elevation per mile. You know, as you see this, the further you go, the more elevation that you have for each mile travelled. So the Bedford level is somewhere round about there or thereabouts. And the figure they use for that over a 6 mile stretch is 6 miles, yeah, times 6 miles times 8 inches. Now that gives you a figure of 288 inches. And 288 inches is 24 feet. And you can check on Rowbotham's book, that is the expected fall in elevation over 6 miles of the Bedford level experiment, 24 feet. Now, when you use the average figure for the globe, and over in the UK, we're nearly at the average, a little bit short of it, but if you use the average of 3,358 feet per mile, then the total fall in elevation over 6 miles is 20,148 feet. Yeah? And that's over 800 times more than the official figure. 800 times more. And it's the same with all the other experiments. The figures that you get using the standard calculation of 8 inches per mile squared is only going to be a very, very small fraction of the average. You will never get the 8 inches per mile squared coming up to a higher figure unless they go the whole hog. It's always going to come up way short. Now, I think the reason they've done this is to make people think, well, would we be able to observe the curvature anyway? You know, the Earth is so big. But what people forget, there's curvature and there's elevation. Now, the curvature might not be noticeable, but the elevation would be. So if we really lived on a ball, yeah, what you need to do is look on this ball, assuming the North Pole's at the top, which is what they tell us. Look where you are. So, Laurie, you're somewhere down in Florida at, what is it, 28 degrees north?
I think
thereabouts?
it's 27 or 28.
Yeah. Well, to work out the angle that you would be stood on the Earth, you take that number and deduct it from 90. So you would be stood out at an angle of about 62 degrees. So when you went to the local coast to do your red boat experiment, yeah, the sea would not be going out from you horizontally. It would be sloping away from you at about 62 degrees. So the whole, you know, thing about doing these curvature experiments, they would not be necessary if we lived on a globe because it would be glaringly obvious. So what everybody's doing on these curvature experiments, they're saying, oh yeah, Laurie, well, let's have a look at where you are. Oh yeah, where's it gone? There we are, Florida. Now, before we start, this is what we're going to do. We're going to tip the ball up so that Florida's at the North Pole, because we always do all the curvature experiments from the North Pole. That's the way we do it, because everybody on a ball will be standing upright. Now, if I got a load of little tiny soldiers and stuck them all at various places on this ball, yeah, the only one who's going to be able to stand upright is the guy at the top. And that's what's probably been the problem here for people to cotton onto this. They're using flat earth thinking or ball earth thinking in conjunction with flat earth thinking, and they're mixing the two up. You know, you have to imagine that you're actually stood on a great big ball, and unless you're stood at the North Pole, you're not going to be standing upright, you know, and you're going to need some pretty strong gravity to hold you up in the southern hemisphere. And that's been the whole problem.
You are going to be standing upright because, you know, according to the globe theory, everybody's standing perpendicular out from the ball. Okay, so yeah, you're going to be standing upright based on gravity and all that stuff, but you're not going to be standing upright, is what you mean.
You're going to be perpendicular to the ball.
You're going to be perpendicular to the floor, to the surface.
If I stick this pen here, right, is a man on the top, yeah. He's still perpendicular to the ball, but now the guy is stood out at an angle. And that's why we had all these memes coming out of all these little children all stood out going all the way around the ball. And that's how it would be, albeit the children were smaller. And the size of the children's got nothing to do with it. You can't do them to scale. So, yes, they will be smaller, but they would still be stood at an angle. If I made this pen 1,000 times smaller to make it to scale, say, yeah, it's still going to be stuck out at the same angle, isn't it? It's not, the curvature is going to be difficult to spot, but the fall in elevation is not, because you're going to be looking down at a very steep slope. And if you're on the equator, you're going to be looking over an abyss. That's how it would be if we lived on a ball. And this is what people need to get their head around when they're doing these experiments, that they're using false data on all of it. You can actually see there's a diagram which shows you curvature, and every last diagram that you have starts at the top of the ball. If they started halfway down, then they'd be getting a whole different result, but they don't, because it's part of the PSYOP. But they don't know it. They're doing it willingly.
Okay, so people have to imagine now themselves, wherever they live, they're on this globe, the 23.4 degree tilt of the globe is considered north, or I mean, the North Pole's considered north, but there's, what's the two different words? One is physical north and the other one's magnetic north. What's the one that's called physical north called?
True north.
True north, okay. So you have true north and then you have magnetic north, which is not exactly the same place because of the tilt, correct?
Yeah, I know, but they're still going to be on a ball wherever they are. And then,
okay, but let me trail this through in my own mind, because I had a hard time wrapping my mind around this too at first. And so the idea is that you have to, in order to figure out where you are and this degree that you would be pointing out from the globe, yes, you're perpendicular, but to the realm, you are at an angle to the surface, okay? And so would it look like, Lawrence, for example, you've seen movies or photographs of San Francisco with the very steep hills, and the houses are built at an angle, what appears to be an angle to the ground, because it is, because all the streets are seriously up and down hills. But in order for the floors of the buildings to remain level, for us to stand on and live on, and so our food doesn't roll off the table, the buildings are what appears to be built at an angle. So equate what that seems like, as an explanation to what you're saying. Is that what we would see, sort of that?
Yeah, but it depends where you live. So where you live, you know, it will be impossible. You won't be able to drive anywhere because you're going to be at an angle of, you know, you're going to be at an angle of over 60 degrees. If you look at a 60-degree slope, yeah, which is something like that.
I've driven through the mountains in Chattanooga and like that.
That's where you are. Now, I'll do it with this pen. Here's the globe. That's where you are. The slope outside your house would be the slope. Can you see that pen?
Yeah.
The slope would be like that pen. Yeah. So if you had to go north, you know, no car's going to get up that. You know, and you'd have to get your mountain boots out to go anywhere. you just won't be able to go anywhere because it's so steep. And if you can imagine that in Ecuador, they decide to build a new skyscraper, yeah, that's where it's going to be. It's going out at 90 degrees. Yeah, one side would be looking out to the sky, and the other side would be looking down to an abyss.
Okay, let me see if I can get my head around that, because I'm trying to also equate it to photographs I've seen that are faked, obviously, that they tried to fake to make us think this is what we would see if we were on the moon's surface. Okay, and I've posted this photograph / meme a couple of times, and it shows the astronauts on the surface of the moon with the lunar landing module in the picture, and the horizon line that you're seeing behind them, it looks to be like 40 feet away, the actual horizon line. So that's how small they're trying to make you think the moon is in comparison to Earth. So if it were that small, by your same formula, then what would it have been like to try to get around on the moon?
It'd be even harder because, you know, it's smaller. So you know, from the point of view of the astronauts, I mean, I've got a picture on my computer of all the landing sites for all the Apollo missions, and a lot of them are near the equator on the moon. So that the spacemen should have been walking. You know, if that was where the landing site was on the moon, they should have been walking like that.
Right,
walking around like
straight
that.
Downhill.
Yeah. And if you could actually, if they really did go to the moon and you had a high-powered telescope and you could actually zoom in on the moon, you know, and they were at the equator, you'd be looking at them. All you would see is the top of their heads.
Right.
Yeah?
I've seen
on the top.
Right.
If they're on the top like that, then you can see them walking around.
Yeah, I've seen that meme too. It's very interesting because there's no way to argue that if they were on the lighted side of the moon, which they were, okay, that's the same face we're looking at us all the time. It doesn't spin, it doesn't rotate, so they would be having to look straight up, correct, to see the Earth.
Well, it depends where they were in relation. Yeah, they would be looking.
I mean, they're on the flat face that always is showing to Earth.
They're up there, we're down here.
Wherever you are. They
would be looking down to the Earth, wouldn't they?
Well, I would think they would have to look like that whole Earthrise.
No, well, the Earth.
Sorry. That whole Earthrise thing they did with, the Earth coming up over the horizon line of the moon.
Yeah.
How can that happen if the moon is always facing Earth? That's one thing.
Well, the moon's above us, isn't it?
Yeah. So how could there be an Earthrise if the moon's not rotating? See that they're mixing their metaphors or something. So, okay. Well, what I wanted to do, and I think you've done an excellent job of just bringing this out there, because in reality, the people that we've introduced this idea, or you have in the group, the Facebook group, flatearthconspiracy.com Facebook group, have really pushed hard back against you with this formula, because I think that they need to have some finite fixed dogma in their head for one reason, something they can really hold on to as this is proof, or this is one of the sure things we know. The other part is that many don't understand that they're, and it doesn't really make sense. You would think they would want this to be true, this formula that you're talking about, versus the 8 inch per mile squared formula, because gosh, it would be so much more obvious. We wouldn't have to sell people anything. They wouldn't have been able to pass the globe off at all if people wrap their mind around it this way. So part of people are going to say, well, Lawrence, then how come no one's ever thought of this before? And I don't know what the answer to that is, and maybe you don't either. Maybe you're just a little more outside the box than most people. But it is worth questioning, because it is being recited. When I say recited, people, once they learn it and it's 8 inches per mile squared, they just repeat it and repeat it and repeat it without ever having looked at it from your perspective that you're showing here.
All right. Look, all you have to do is compare the average curvature of the Earth, and those figures I've given you, that they cannot be challenged, because those are the official dimensions of the Earth, and that is the average fall in elevation per mile. So when you look at the Bedford level experiment, and they're coming up with 24 feet, and if you use the average, it's over 20,000 feet, 20 to 20,000, 24 feet to 20,000. It's 800.
Not only should he not have been able to see the flag on the boat or whatever it was they were filming. I'm pretty sure it was a flag, right?
You won't be able to have canals. All the water would drain out. Canals have to be level. They have to be on level.
Think of the waterfalls and the lakes, and there would be no lakes because all the water. Okay, so then they're just going to go, well, duh, gravity's holding everything on there.
Well, the ballers will say that, yeah.
It's one thing for gravity to overcome spin to cause the gravity, but it's quite another thing for gravity to overcome an equatorial straight downhill slope backwards.
Well, if we lived on this ball, all I have to do, I haven't got any with me now, live on this ball, I stick on some little tiny soldiers, the ones that they use on the little battlefield, the little plastic ones, and I dot them all over. The only one stood upright is the one at the top. So if we lived on the ball and you lived anywhere on the top, you're going to be standing out at an angle, and it would be very difficult to stand up. Where you live, you just couldn't live there. Mountain goats will struggle where you live because it's over 60-degree angle.
Yeah, there would be no people in the southern hemisphere, hemiplane.
Yeah.
There would be no people at all. Everything would have fallen off.
Yeah, that would be the reality. But,
of course, like I said, they're just going to keep coming back with gravity. But since we know there's no gravity.
All right.
We know there's no people standing upside down. Hi, Australia, New Zealand, South Africa.
Gravity isn't going to change your angle, though, is it?
No.
It's only going to change the downward force on you. So you're still going to be stood out at an angle, gravity or no gravity.
Yeah, if we all were under the effects of gravity, even if we gave the Globers, okay, gravity, you own it, we got it, we're going to use it for this exercise. Okay,
gravity,
you got gravity.
Gravity doesn't make somebody upside down stand the right way up. It just holds people down in theory. Now, people say, well, everywhere's up. There is no up or down. Well, let's give you an example, Laurie. I tie you up by your ankles with a big chain and get one of these great big cranes and hold you up by your ankles and lift it up to, say, 200 foot and let you dangle. You're going to know the difference between up and down, aren't you? Yeah? You'll certainly know what down is because you'll be looking down at it.
Right.
Yeah.
Boy,
So
I tell you what, first I'm jumping down this 7,918-mile tunnel, and now I'm dangling upside down from my ankles. Boy, the globe, trying to figure out the globe and prove the globe is a joke is that's a dangerous occupation.
it is a complete joke. And that is the biggest proof because this is what I was saying.
Born upside down though, Lawrence. Okay, now here's another thing. Let's extrapolate this out a little bit. Okay, the Earth has gotten pretty small with regards to people relocating, migrating, moving, so on and so forth. Okay, so let's say I was born in South Africa, and so I lived the first 20 years of my life upside down on this ball with the vantage point that an elevation and curvature and everything that I've born into, okay? And I'm used to that. How in the hell do I reorient myself if I suddenly move to Canada? Opposite, upside down, right side up, one hemiplane to the next hemisphere, whatever. How long would you think it would take for me to reorient myself to living right side up versus upside down?
Well, I don't think you'd be able to live in Africa anyway. I think the only place you could live is in the 0 to 10 degrees. 80 to 90 degrees north. Everything else, the steepness would be so bad that you wouldn't be able to get around, and vehicles would be impossible. You couldn't travel anywhere. And it's the same with aeroplanes, isn't it?
This is that time when you really wish that, you were asking this question of Neil deGrasse Tyson, just so that we could all get to hear what his response to this would be.
Well, that was in the early days of Flat Earth, I would bring this out and I'd do my talk and I'd say, so you think you live on the ball, yeah? And on your ball, it doesn't matter where you live, you can stand upright. So I would give them the ball, yeah? And then I'd give them a box of soldiers and a bit of glue. And I said, I want you to show me with this model how everybody can stand upright at the same time on the Earth. And of course they couldn't do it. And then I got my little boats out and I'm saying, well, I've been on cruises everywhere, and the boat may bob up and down a little bit, but it's predominantly absolutely flush with the ocean,
right.
And it's level. Now, if you're sailing on a boat, the boat's going to be sideways on if it was going east-west, and if it was going north, near the equator, the boat would be traveling vertically north or south.
If the boat was sideways going around the equator, for example,
the boat would tip over, wouldn't it?
Well, even with the effects of gravity, if you tried to add that gravity back in there to hold the boat to the Earth, how do you manage to keep everything on the tables and people sitting on chairs sticking out like this?
Well, that's why the globe is such a joke. And when I get into discussions on people's YouTubes, and they start the globers, I always ask them these questions. Please draw me a model as to how everybody can stand upright on the Earth, or how boats can travel level all over the Earth.
Well, but see, Lawrence, again, every time one of these kinds of questions is answered, the pat response over and over again without any other is the first one but it's so big you wouldn't notice.
It would still be big. You wouldn't notice the curvature, but you would notice the fall in elevation. If you walked up a 10-mile slope, Laurie, yeah, that was really steep, yeah, or you walked up 100-mile that was at the same angle, there's no difference, is there? It's just a question of the angle. The angle is what creates the fall in elevation. The steeper the angle,
right, exactly,
the bigger the tilt. Yeah, so it doesn't matter how small you are. An ant on this tiny ball on the side, he's going to know that he stood sideways on, and only ants can stay on it, can't the humans? If I got a great big ball, yeah, and hoisted it up, and then said to you, let's go a 1,000-foot ball, and I stick it outside your house, and I said, Laurie, I want you to walk down to the equator. Don't worry, gravity will keep you pinned to the ball.
Well,
how far would you get? How far would you get?
Okay, so I was just trying to visualize. Okay, you're talking about an ant now. All right, so I'm trying to visualize to scale an ant the size of, a person, and walking on a ball the scale of Earth, what that would look like. Okay. So I'm seeing the ant, because ants can walk on the ceiling. I mean, they have that ability. Humans can't really do that, but ants can do that, bugs. So if we had a little ant walking around a ball the scale of Earth to the ant, then what would the ant notice? Does the ant know when it's walking on the ceiling that it's walking on a ceiling versus walking on the floor?
Well, I don't know the thoughts of an ant, but I would imagine they would know when they were upside down and when they were the right way up.
You would think.
And we're talking about humans. When you go to the fun fair, maybe you don't go anymore.
I know when I'm upside down, I feel the effects of upside down.
When you're upside down, yeah. So
if somebody conked me out with like a sedative, okay, and did what you said, put chains around my ankles and hoisted me up while I was out, gone, cold, with a sedative, the moment I woke up, I would know I'm upside down.
Well, exactly. So if you lived on a ball and you were at the bottom, you would know that you were upside down. And that's been part of the psyop. If you start looking at Robotham's, I haven't looked at all of it, but Robotham's evidence for the flat Earth is mostly disinfo. And when you get Eric Dubay quoting from his book, and his book is just a reprint, in a different order of Robotham's material.
Sure.
That's all he quotes things from Robotham, who never left the UK, and apparently he was a Freemason. And then he quotes old quotes from sailors getting lost and stuff like that in the Southern Hemisphere and stuff like that. I'll tell you what's quite interesting, which I think this may be controversial as well, but we keep getting told that it's a lot colder in the Antarctic than the Arctic. Right. But Nathan Oakley had this guy on his show about a few days ago who met up at that meeting in Oxford. This guy worked at one of the Antarctic research stations for over 12 months, and he was asked about the temperature. And it wasn't that cold. It might have gone up to minus 30 or minus 40. And in my view, the temperature is just as cold up north. Let me give you an example. I'll do a screen share. Let me just bring this up.
Well, no, wait. Let me make sure that we're clarifying this. The guy is he reporting the temperature during Antarctic summer or Antarctic winter?
In the winter, yeah.
Okay.
Just bear with me.
Versus the Arctic winter. Is that what you're saying?
Yeah, just bear with me a second now. You just talk a bit, Laurie, while I find this.
Okay, well, I got something to talk about for a minute.
Let me just find.
I watched the movie Gods of Eden. No, Gods of Earth. What is it called? Gods of Egypt. Sorry. Space. Gods of Egypt. And I watched it twice. I mean, it was remotely entertaining, but this is one of those new movies, 2016, that addresses or at least intimates that the Earth is flat. And the reason why I say that is because I stopped it a couple of places during the movie to try to get my head around, are they really showing animation that the Earth is flat? And so at one point in the movie, it's called Gods of Egypt, yeah, because it's about the giants that came and Ra's sons, Osiris and Set, who came and seeded the earth with humans. And it was pretty well done, actually, for the part where, you know, they show the humans together with the giants. And boy, those green screens, they can really do some fabulous things with those today. You know, the giant was talking to the human, the little human, and he was about twice his size, if not a little more, than the human. But anyway, there's a scene in there where Horus, the son of Osiris, goes to where Ra is, and Ra is floating in a sea of what looks like water with glittery gold bits in it, and asks Ra, his grandfather, if he can have some of the waters that this chariot / ship is floating in. And interestingly enough, they also show that Ra is dragging the sun behind him with a chain, a big giant chain. It's a big flaming ball of fire, the sun, and he's dragging it behind him as he travels across the earth. And when he gets to the edge, instantaneously, as he goes over the edge, he's coming up the other side, which you would appreciate this, Lawrence, with the portal / time loop thing. And suddenly he goes out one side, and suddenly he comes in the other side, still dragging the sun. So in the abyss area, which is underneath this flat disc they're showing in the movie. Now, first of all, let me explain. I do understand it's a movie, and I do understand that it is somebody's imagination based on old Egyptian stories and hieroglyphs and mythology and all of that stuff combined. But the point is they chose to depict it this way. And so Ra is the only entity that you see on the ship, and he's busy. I mean, he's like fighting off the creature, the beast that wants from the abyss that wants to take over and eat up the earth. It's kind of like anti-creation that wants to consume Egypt and the earth. So then there's another part later in the film where Set is got a big globe thing with and I'm sure you've seen it, the flat earth disc is in the center and you can flip it over, and on the underside is the equivalent of the underworld or hell. And it was just right there. I mean, they made sure that you understood that this is what they were doing. So I watch these kinds of things for the purpose of understanding the purpose of their predictive programming and what they hope to accomplish with it. And the idea in as far as I'm concerned is they're pushing, Hollywood is pushing for people to start wrapping their minds around flat Earth and the disc shape and the idea of the ancient alien technology, blah, blah, that comes from, the giants, the biblical fallen angels who were giants. It's an interesting movie to watch. Not that I want you to support Hollywood by going and renting it or whatever. Maybe wait till it comes out on Netflix. But it is something that people in the flat Earth community should see and understand is why they went in this direction and what it is they're trying to promote. Because this is the kind of thing that scares the crap out of me as somebody who knows and feels extremely confident that we don't live on this little pizza pan disc. with edges that just fall off to nothing. But that's what they're promoting. So that's my flat Earth movie review report.
Right. Let me just share this just as a little demonstration.
And Lawrence could care less. Call me filler.
There we go.
All right.
Sorry. Okay, so a little video here. Have I got the screen? Yeah.
Yeah.
Laurie?
Yes.
Okay. So this is up in, I think it's Siberia.
Yeah, I can see it fighting. Good.
That was a glass of hot water. Yeah.
Uh-huh. Yeah, I saw that video. It's pretty amazing that it froze instantaneously. Go ahead.
Let's see what this one does.
See my face better? Well, I'm too far out. I mean, I can use it. See it? Whenever you're ready. Which way are you going? Okay. Ready? Yeah.
So that's boiling water to snow instantaneously. Let me stop the sharing on that. And
okay, so the first one was the Arctic and the second was Antarctic. The first one was Siberia.
There was one in Canada and one in Siberia. I mean, I've seen one from Fort McMurray, which is where the oil sands are up in Canada, where they extract the oil from the sands. And the temperature there at this time, when they did the demo, it was -50. And the guy who was on Nathan Oakley's show, or the show that... Is that you? Oh, sorry, is that me?
That's you.
Sorry, that was Roger Rabbit or something. The guy from the Antarctic, we went to the Flat Earth meeting, he was running through some of the temperatures out there, and he didn't come up with anything over more than about -35, -40, if my memory serves me right. No, he was in Antarctic, and they'd have us believe that it's -90 out there. But I think the temperatures up in the northern parts of Siberia and Alaska and places, really north, they're going to be comparable to what they are in Antarctica. They just want us to think that the Antarctic is so much colder. And then I don't know why they want to use this as proof that the conventional flat earthers, they want to use a proof that there's less species of animals at comparable latitudes in the southern hemisphere. I haven't looked into that to see, but there may well be a good reason for it. I mean, you've got the Sahara Desert, which isn't on the equator, as one of the hottest places, and then you'll go from a desert into a lush green place somewhere else in Africa. So you've got all sorts of variation on this flat plane, and trying to equate that to back up their model seems a bit of a limp dick excuse to me.
Well, I mean, it should be obvious to anyone who really takes the time to look at a globe model where certain hottest places on Earth are as far as desert, and there's no equation to say, well, it's because it's located here, because Mojave is not at the equator, and Sahara is not it's not at the equator. There is what's the crap? This is what happens when you just have too many things on your mind at the same time. Jungle, Hawaii, for example, one of the most highest rainfalls on Earth is, I believe, in Kauai. And as far as where its longitude is, compared to some other rainforest in South Africa, for example, or in Central Africa, Central South America, they don't equate as far as latitude, correct?
Yeah, I mean, if we run a spinning ball, then either everywhere would be a desert or there wouldn't be deserts. You wouldn't get that. You'd have to have the if it was a ball, it would have to be locked in position with the sun on it for that area to be a desert. If the place is spinning round, then you wouldn't get you know, these huge variations in climate. It would be pretty much, you know, per latitude, it would be pretty much similar everywhere.
Well, it's interesting that we brought that up because in that Gods of Egypt movie, one of the reasons why, well, the reason why Horus went to visit Ra and get the waters from a sample of the water, one drop does some amazing thing on Earth. And he went there to kill the desert of Egypt, outside of Egypt. What kill the desert means, I'm not exactly sure what that means, but they showed in the film that at one point Osiris had these beautiful gardens near the palace or whatever in Egypt, and it became all extinct and dead and desert-like. And so they moved to where the Nile area was and so on. So they were trying to make some correlation to areas of the earth that at one time were lush and beautiful, and now they are deserts. Same thing they keep trying to come up with in Antarctica, that at some point before there was lush, beautiful Eden-like landscape in Antarctica. And that all was because the Earth tilted on its axis in some way back however long ago and froze it. So why they keep trying to recreate history of Earth is beyond me, because every time they do that, they catch themselves in, for something they're trying to cover up for their own good for over here, it opens a door of, oh no, wait a minute, over here. So, he's got more video. You got more videos?
So I've got one to show. I was going to play one when we've got, you know, got a minute, because Ronnie was going to come on the show tonight. I don't know what's happening.
I'm not exactly sure what happened with Event Skeptic. He was supposed to come on tonight, and I did speak with him earlier in the week for a while on a hangout, but I have been trying to send him an invite and get him on for the last hour, and can't raise him. So maybe he got the day confused because we're used to doing Sunday shows. I'm not exactly sure, but whatever happened, he's not here. So our apologies if it was just some miscommunication about the day. Then we'll reschedule and have him on if he's still willing to come on. Maybe he has been talking quite a bit about free energy's work and square flat earth and some of the other aspects of the things. The diamond map, he did a video about the other day. So not sure what happened, so sorry.
All right. Well, he put this video out that really fascinated me, and if he'd been on tonight, I was going to ask him about it. So what I'd like to do, it's only a short video. It's not that short, but it's quite short in the scheme of things. I'd like to play the video and for the viewers to watch it. And if they've got any questions, then, you know, ask them on this video where you ask questions. And I think Ronnie watches the show, so maybe he can answer the questions. And if he comes on next week, maybe, you know, there'll be more questions for him when he comes on. So if I can just dig this out, you can grab a coffee or something now, Laurie, or something, while I get this going. And hopefully Ronnie could explain this to us in the simplest possible terms so that we get it, because I don't know whether it's him who's actually talking or somebody else, and I don't know who the other person is, but it's a very interesting video. And the interesting part about it for me is that, you know, they were using the same diamond shape map that we've got, and they put this out a couple of months ago. So I'm screen sharing. Okay, let's bring it up. And this is called Diamond Whisper Electric Flat Earth Comparisons. So let's put that on full screen.
Turn your volume down a little bit, Lawrence, please.
Turn it down a bit, okay.
This world will be shaken by a whisper.
I don't know what this is supposed to represent, this part right here.
When I feel my way falling down, I think of you, think of you. When I feel I can breathe no more, you speak to me, you speak to me, you speak to me.
Sorry for those of you who are listening to this on a podcast later, because you didn't get to see that. But when we're playing videos, it's
I'd like to start off by stating that the video is a demonstration of electrical properties, inspiring thoughts, and new ways to perceive the world around us. Stating that I am a flat earth believer, I as well find many things that just don't add up. The perceptions and observations cannot match any model, reality, or thought. So in my opinion, instead of stating obvious things and showing clear and simple examples of things we see every day, I try to inspire to push the boundaries of thought, idea, and discovery. And I suggest anyone listening to this video, anyone even thinking about making a contribution to the truth and our reality, to don't wait, don't hesitate. Now is the time. Thank you for taking the time to hear me out, and I wish everyone well, except for the New World Order. I wish them to hell.
Okay, this is magnetic flux part 2. And I was making the point here with this closed surface that when you have closed surfaces, the DAs always go normally out of the surface or perpendicularly out of the surface.
Lawrence.
And that,
Hello?
so if you have a line coming in like this, then the flux going through this part, this little DA here, is negative because your DA is outward and your B is that way. And so the angle between those two vectors is 180 degrees. And so if you take the cosine of 180 degrees, that gives you -1. And so basically you count the lines going in as negative and the lines coming out as positive. And then if this field is going to be straight across, would you see that the flux through if the B is just going straight like that, then this DA has no flux through it. The DA
Lawrence.
Yeah.
through it.
Can you pause that, please?
And this
Yeah, sure.
magnitude. And the least flux.
Okay.
This is a little too taken out of context for people to be able to understand. So I would prefer at this point to post the link to this video in the description of our video right now, and so that people can go and watch that, because I watched that video myself and really got kind of bogged down in that whole flux thing he was talking about. But if you watch the whole thing, then you kind of can get it a lot better. But taken out of context, it's pretty hard to do. But it was interesting that he was doing it on the diamond map. That's for sure. And also that it seems to be that he was talking about this with regards to the flux, that he was talking about the energy in and out of any particular area of Earth. So that would relate to time portals or whatever you want to call them. And so it seems like that's a very positive thing, that more people are working on trying to understand and explain what it is we were talking about from the beginning, of why the diamond map works physically as far as a representation of the continents as we know them, and the Earth's surface as we know it, even though we are unable to perfectly explain how people can continuously go from east to west without falling off the edge, and or without with it being seamless.
Yeah. And here's another thing for you. Just bear me a second. Let me just find that. Let's have a look.
Lawrence works at home, so he just has an essential oils business. So he has the benefit of being able to listen to and watch videos in the background while he's measuring his oils formulas. And so he turns me on to a whole lot of stuff, and he's apparently doing the same to
let's
you
just
now.
have a look at this. Probably think I'm labouring a point, but let's have a look. There we go. Not those. Oh, that was Chicago. Yeah. Yeah. That was just my Chicago one, saying that if it was on a globe, this view of Chicago would not be seen, but it wouldn't be level like that. It would actually be sloping away at an angle of 48 degrees. You'd be looking down at the sea. I've got another one here, which put the other figures in, if I can find it. There we go. File. Where's that gone?
It's all right if you find it. So, well, what do people that are listening? I want you to, what? Did you find it?
So this is going back to Chicago. I've got the other one. I'll just show it in a minute. 8 inches per mile for Chicago. This is the way you've got these buildings over the water. The falling elevation would be 2,321 feet. But if you use the Earth's average calculation, average falling elevation, and Chicago is approximately halfway between the North Pole and the equator, so near as damn it's going to be the average. It would the falling elevation would be 198,000 feet, not 2,000. So you can see there's a huge difference between 198,000 and 2,000. You know, and that's why I think that's a bit of a psyop. But I wasn't showing you that; it was something else. Let me just take that off. Where's that gone? That was it. Yeah. So, all right. Here's a question for you. Like, can you see that AE map?
Yes.
All right. Where's east on this map?
There's no east.
Well, apparently east and west goes in a circle.
Right.
On this map, but in real life, east and west is a straight line, isn't it?
Yes.
You see, their equator's going around this bit there. You know, just under that pointy bit in Africa, that red line there, and that's going to be
on the AE map. Every east and west from anywhere is a circle or an arc, and north is always to the center, not up or down, and south is everywhere away from center.
If you were going to sail around the AE map, if it was real, and you were going to sail east and get back to where you are, you would be forever turning. You could not sail in a straight line, which you can on our reality, you know. And navigation would be impossible if you're having to turn all the time, to keep in the right direction. You know, you'd be forever turning and trying to navigate in the right way.
Well, that's like that old story about the hiking in the woods, and you have humans have one leg slightly shorter than the other, most people, And if you think you're walking in a straight line, eventually you'll come back to where you already have been, because you'll be slightly walking in a circle. I think that's an old myth, but there may also be something to it. I don't know.
Yeah.
So I'm trying to get visualizations in my head because I'm a visual person. As an artist, I have a hard time creating something until I can imagine it in my head. And so I'm thinking of a time when I was in Switzerland and I went up into one of the lower Alps, and I went up on this. There hardly is any other way to get up there, but it was this train that took you up to the top, and there was a touristy place up at the top and a restaurant and so on and so forth. But the train was really interesting because it was on a ratchet type gear system where when you went up, then it ratcheted to keep you from going back down. So as you climbed, you ratcheted your way up to the top. And then it was sort of a reverse going back down. It wasn't just a woohoo, sailing back down. So, but when I was on the top or close to the top, there were some sheep that were grazing on the hill there. And it was pretty funny because they literally were, sideways. Trying to stand. I mean, they couldn't stand straight out from the hill, okay, because they would fall over. So they had, their feet angled to where they, were propping themselves up to the angle, the opposite angle of what would make them fall over. It's kind of hard to describe, but you understand what I mean. And I, I kind of marveled at that. Imagine spending all day on the side of a hill where the beautiful green grass is. That's the best place for it. And that's the only reason why they would travel up there to eat it. But imagine standing all day with trying to prop your one leg to the other leg so you wouldn't fall over. Are you saying that's what it would be like to
exactly
stand on a globe?
Spare me. Here we go. This is what it would be like. Here we have got a little image here, so let me just go back to the screen. And this would be something what it would be like where you live. It might not be quite as bad as this, but it won't be far out. Just bear with me a second.
All right.
Here we go. Let's go back to the Hangout. Share the screen again, and you're going to love this. There we go. Right, here we go. Where's that gone? There we go. Yeah, there we go. So there we go. Now, can you see that goat?
Yeah, I've seen those goats. They're awesome.
Well, that's probably what it'd be like in Florida, Laurie, where you are. It would be slightly less steep as that. But you can imagine that, driving your car up that hill would be slightly difficult. There's a few more here on slightly different angles. So you can see these creatures, on these slopes. And, there you go. That's like on the side of a dam or something, isn't it?
Yeah, these really are real pictures of real goats.
That one there, Laurie. Okay, that one there. That's what it would be like where you are. That's about the right angle. That's probably an angle of about 60 degrees or so.
Okay. Yeah. I'm getting there. I'm visualizing it a little bit better all the time.
Yeah.
I mean, I can't even imagine what it would be like to look out over the Gulf of Mexico, which is, I live pretty close to the Gulf of Mexico, and looking out over the water and see the angle. And having to stand there on the beach, counterbalancing myself to make sure that,
You would probably have to look at that one. Yeah. You would probably have to go around on all fours. You'd need shoes on your feet as well as on your hands as well as your feet, because, the angle will be, you won't be able to walk normally. I mean, how the hell did that get there?
That's amazing, these goats.
Yeah, so there's the mountain climber, and there's the goat. They're pretty good, these goats, aren't they? That's why they call them mountain goats.
Right.
So let me just come out of that. But that's what reality will be like, when you're getting towards the equator. You're going to be looking at ridiculous angles there where it would be impossible to function. You know, everybody would be moving up to the North Pole area, or as, you know, as high as you could, where the angles are not quite so steep where you could possibly live. But you know, where you are, it'd be impossible.
And it would literally be impossible below the equator.
Yeah,
I mean, everyone would have to have stickum shoes on their feet and hands just to hang. You know, I'm sorry, this is just over the top for me this week. I mean, I've really been trying to wrap my mind around this since you've been posting it in the group on Facebook about the curvature formulation. And I know there's probably people right now listening to this going, are they absolutely out of their minds? I mean, but this is good for flat Earth if it's, you know, more people would be able to get their mind wrapped around it, because 8 inches per mile squared of curvature would be measurable, would be noticeable. But for crying out loud, this puts that to shame. Imagine, you know, try to imagine flying in a plane, literally upside down. I mean, how would you navigate? How hard would that be to navigate around this ball? To, you know, I don't know. Maybe I'm overthinking it, but I don't think so. I'm kind of getting now where my mind's getting wrapped around it, Lawrence, a little better. So I want to go, you know, this is so ridiculous that I can't even believe we're talking about it. But if this is the case, then it needs to be talked about. It needs to be yelled out up and down the street. But we definitely need to make some kind of a visualization, a diagram, or a PowerPoint present, something. I mean, the goats is pretty much of a deal sealer to me. Just the goats.
Yeah, the goats would be all right.
I mean, if we could make
the human race would be wiped out. It would be a population of goats on Earth if it was as fair.
and,
you know.
and insects that have sucky feet, you know, little sucky things on the ends of their feet. Or if you were like the glass cleaner people or the glass installers that had those suction cup things that you, and then you could just like go around with that. All right, so we're going to keep revisiting this. Now, for those of you who are listening, who are saying, you know, these guys are disinfo agents, they're psyoping us, they're screwing with our heads, they're, you know, trying to make flat Earth look like the laughing stock. No, absolutely not. We're introducing a concept that people need to think about. And if and when your mind can go ding, 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 and you get the goat thing and you get the angle thing, and you understand that measuring curvature now is a joke. Once you get this, elevation is something you need to wrap your mind around. Okay. When they do house plans, you know, they show elevation from every side, front, back, and at least one side. But if the land that the house is on is completely flat, that's one thing. But what if you're trying to build a house on its side of a hill? The elevation of the different sides of the house are going to be radically different. And you have to try to maintain level inside the house for the people to live in and be able to stay in bed without strapping yourself into it to sleep. Or you know, having a hammock where, you know, you get in it and you can swing freely sideways. I mean, I'm not making fun of it. Trust me. I'm on board. I get you. I get where you're coming from with that. And now I'm going to try to figure out what to do with it. And what we should do with it as a community. Because if people won't go here, won't get this, that if in fact we did live on this globe that is proposed all of our lives, this is what we would be seeing. This is what we would be experiencing.
Yeah, I've got those houses. I'll just pop on again, Laurie. I've got those properties. Hang on. Tie screen, share. There we go. So if you're there we got San Francisco. That's
right.
That's a very shallow hill. You know that it would be much steeper than that in reality. You know, but everywhere you looked, there will be hill. Wherever you are on a globe, apart from at the top, everywhere is going to be up or down. There's going to be no flat areas. The only flat areas you could have were ones that were carved into the surface of the, you'd have to chisel it out of the earth to get anywhere flat. Anything that's built on the surface, that you're going to get stuff like that picture there, and that will be on the places where it wasn't that steep, because that isn't that steep an angle. That will be somewhere towards the northern end of the northern hemisphere.
Well, I mean, it's steep enough of an angle that some of those houses foundations are built on a 45-degree angle.
Yeah.
I mean, I build stuff all the time, and I have to use a square and a compass. Interesting that you have to use, not a compass, a square, framing square, and a it's not a compass. What is it that measures the angle?
Yeah, why is it?
The little tool that you put in there to measure the angle. Compass. Yeah.
Protractor. Yeah.
Protractor. And, if you're doing crown molding or something, and you've got to put two crown moldings at an angle at a steep point of a ceiling, an A-frame ceiling, you have to know this angle, and you have to know this angle of the going up against the ceiling and the wall. So yeah. I mean, I'm getting where you're coming from.
Everywhere can't be up, so it amazes me how many flat earthers, call themselves flat earthers, and that they think everywhere is up, and it can't be.
They think everywhere is center or out.
If everywhere
was
up
in the AE map
on a globe, then you should be able to make a model of it, and you can't. So when you're doing experiments for curvature, then you need to look at the latitude of where you are. Now, I haven't got Excel on this computer. If I had it, I could write a little program where you could tap in the latitude of where you are, and it would work out the curvature per mile where you are. I mean, you can probably work it out roughly yourself anyway, if you've got some basic math skills.
Well, I mean, we need the mathematician people who have been doing these math curvature calculator type things, Brian Mullen and Michael Conkey and some of the other guys we don't want to hear that it's ridiculous. We want to hear if you can model it as that would be what the Earth would be like if we lived on a globe.
Funny you should say that, Laurie, because Brian Mullen put out a video in the last week, and he was doing the 8 inches per mile squared again, and he had his little thingy at the top where you've got the lines coming out and coming down.
Right.
Where was he starting his curvature? He was, I think he was talking about Chicago or somewhere, but he was taking his curvature from the North Pole. So you take Chicago, and then for your demonstration, you use the North Pole. Well, that's fucking stupid, isn't it? You've got to take it where fucking Chicago is, which is whatever, it's about 42 degrees, isn't it?
Well, now that we understand that, I would like to see somebody address it. I mean, someone, I personally have a mathematical learning disability from birth, so I can't do it, but if I can visualize it, then I can see it. If you want to make fun that, of course, Laurie agrees with Lawrence because she's like a math nerd or a math derp, then okay, regardless. But this is based on visualizing living on a globe and I have excellent visualization skills, and can, if it can be imagined, then I can see it in my head. So I'm when people say, oh, Lori's always backing up Lawrence. Not always. And you can testify to that. If I don't see it and I don't understand it, I'll tell you that, and I do. And we keep working on it until I either see it or I just go, nah, this one's not going to fly with me, Lawrence. So I'm okay with this. I don't want to belabor the point. We've put it out there. Others can laugh if they want, or they can look at it seriously. But if you won't even look at it, then you are no researcher, because this is the kind of idea that should help flat earthers get a better grasp on what it would be like to live on a globe, so that they could explain it to other people who are globers and say, did you ever think about this? Of course, you have to get the goats and the San Francisco pictures out, or some Frank Lloyd Wright. There's a house, very famous house that Frank Lloyd Wright built. Let me see if I can find it. That's hanging off the side of a hill. Okay, Frank Lloyd Wright, and let's see, Cliff House, I think it's called. There we go, Sea Cliff. And let's go to images. And is this it? Screen share. Okay, that is a house built on property that requires the angle of the elevation to be pretty much, what is that, 45 degrees out from the surface?
It's probably about, well, it looks about 30.
Yeah. So let's see, there's another one that I was just looking at too. Okay, is that one up on screen share?
Yeah.
Okay. For the topography of the land, of course, people are going to say, well, the land is not, nobody ever said all the land was flat just because the surface is flat. Obviously, there is hills, mountains, terrain, valleys, so on and so forth. But the idea is to try to wrap your mind around not just one part of a certain section of the globe being hilly or angled, but the whole latitude line of that particular side. So there you go. What else have you been thinking about this week, Lawrence? I want to. I know you constantly are questioning all of the flat Earth dogma. So,
well, obviously, temperatures don't seem to add up, and somebody who's watched all our shows actually posted the Chicago skyline thing, and I'm going back to that just for a minute. But I passed a comment on his page saying, that's completely wrong, and told him what he would be looking at, and he said, yeah.
Excuse me for a second. Now that you're not using your whiteboard anymore, can you move your camera so half your face is not on camera? There you go. Or yourself.
Yeah, this chap's watched all our shows, and he was agreeing with me that he found it incredible, but he couldn't argue with it because he looked at the maths. This is very simple math. Once you look at the math for the Earth as a whole, what the curvature would be, you can't argue with it. And somebody made a post about the Bedford level experiment in the UK, which they're doing in early July. I think Dave Moore, otherwise known as Allegedly Dave, is organising the Bedford level. And I posted on that thread saying, you know, if we really lived on a ball, then the UK is at about latitude 50. And at latitude 50, the UK would be at an angle of about 40 degrees. And you'd be, you know, you couldn't have a canal at 40 degrees. It has to be level. So, you know, canals wouldn't exist if we lived on a ball. You couldn't build canals apart from at the North Pole, and they freeze over there. So you couldn't really build them anywhere.
What about the canal? What about the Panama Canal or the Suez Canal? Those are pretty close to the equator.
All the water would drain out because
it all flush up the side, right?
Yeah, it would all spill out. You know, that's how it would be if we lived on a ball. And if you wanted to go shopping where you live, you know, and you were going south, you wouldn't need any petrol in your car. You just take the handbrake off and you know,
put it in neutral and coast to the mall.
Yeah, but then you'd have to abandon your car because you couldn't get home because you've got a
no, it needs mountain climbing gear or one of those ratcheted.
You'd need a rope.
Trains that goes up in the Alps.
Everybody would be going around with ropes and crampons on their feet. And
oh God, I just got this visual of everybody having mountain climbing gear all strapped to their waist and, you know, harnesses on and bags full of, what do they call them? Pitons.
You could have down to
and oh wait, that can't work because we don't have any rock here. It's all sand. How do we embed anything in the sand? So then that means we'd have to have a bunch of come-alongs everywhere that we could just keep rationing our. I'm sorry, you know, I don't want to belabor it. But it's something that needs to be addressed. For those who say no, it doesn't because it's completely ridiculous. Well, we thought that about. You thought that about the AE map too, until quite a few people now are off of that and on to not using that as the official map of the flat Earth community. So we're not saying we're smarter, wiser, smarmier, or anything else than everybody else. We're just saying we're taking the time to ask the questions, and we definitely think you should question what we're coming up with as we question, because if we're wrong, show us where we're wrong, show us where the reasoning is erroneous, because I didn't just nod my head like a doll in the back of the car window, you know, that does that. When Lawrence brought this up, because I don't do that. If I don't get it, I don't get it. And so,
there was something else. I'm not too sure whether I mentioned it last week, Laurie, but can you bring up on the screen time and date at the spring equinox? There's something I wanted to show people a bit more graphically than what I did last week. And if you can just move it along as I asked you, then they'll understand it.
Let's see. Time and date, calendar, and date.com. And we want sun and moon, right?
Day and night map, which is probably sun and moon.
Day and night map, got it.
For the spring equinox.
All right, let me do a screen share. And then go back there.
All right, so just move the...
Okay, let's see, where do I go to pick a day?
You move further down, move that.
June, what do you want? The June solstice?
No, I want it when the sun's over the equator, which is March and September. So it's either
all right, here's March equinox.
Okay, so if you look at where the sun is, well, hang on, yeah, that's the, okay. Move it across again. Move it Well, I want to see the one where you can see where the sun is, where it shows that's showing the moon, isn't it? More than anything.
All right, hold on.
Oh, sorry. No, that's right. So if you look at that there now, yeah.
Okay.
Then where the sun is now, yeah, the visibility to the sun is where it's bright light, and then obviously you've got the different shades of blue where you've got the twilights and things like that. Right. So if you move it across 6 hours, just move the sun 6 hours. You've got that option, jump 6 hours, and you'll see that every 6 hours the sun moves a quarter of the way across the earth. So where the sun is there now, yeah, where it's directly overhead, the people there can see they see the sun 6 hours either side, yeah, which is about 6,000 miles, maybe just a little bit more. But when the sun is move the sun along till it gets to the very edge. So give it another 6 hours. And another 6 hours. Just get it right to the edge. Yeah. Okay. So
another hour.
So yeah, another hour. Yeah.
Okay, it's pretty close.
All right. So okay. So if you look at that there, you've got places over on the opposite side to the sun in daylight. So how far is the sun away from there? Is it the distance from the left-hand side to it, or the difference from the right-hand side to it? Because obviously you couldn't have that side of the map lit up. How can it be lit up when the sun is on that side? And also, the visible range of the sun is 6,000 miles for people where we live and on the equator. But people up in upper Greenland and places like that, they're able to see the sun from more than 6,000 miles away. So they cannot be seeing the sun directly. It's got to be a reflection off the magnetic walls for them to see it. Because if you could see the sun from 9,000 miles away directly over there, then you'd be able to see the sun where we are from 9,000 miles away, but we can't. We're restricted. So that is more evidence that there is a magnetic effect, and the sun has to be generating this magnetic effect off something, and it needs to be these magnetic walls or some other mechanism that's making the sun reflect off something and show up in much bigger areas. I mean, that looks ridiculous, doesn't it?
Yeah, well, I mean, it looks ridiculous, except for if you go back and do the opposite thing with the 12 hours like we started. It's interesting. Now you've got two squares, one on the left and one on the right, and you have basically a square in the center. So, boy, why they've got the moon so huge on this particular day. Wow, it's like almost double the size, 3 times the size of the sun. I don't know what the significance of that is, why they do that on this website.
Can you move it to present day? So we've got the sun and stuff as it is right now. Can you go back to the present day?
Let's see, present day. There should be one click, but let's see.
I'll just do a backspace. It'll take you there, won't it?
Oh yeah, well that'll take like 10 times. No, I never went there to present. I never started with present day.
All right, I'll forget the current.
Sun and moon.
Day and night map.
Night, and that should be Saturday, June 18th at 10:34 p.m. Okay, that's right now.
Yeah. So when you look at that, and you look at it, and you just keep progressing it through, it seems really weird that in terms of the land masses, half the land masses are not in dark and half in light. It's more like 3/4 of the land masses are lit up over a 24-hour period, and only a quarter of them in darkness. So most of the darkness is over the seas. Yeah. So you look at that, and you look at, if you actually calculated the land masses of that, you would see that most of the land masses are actually in daylight. And probably about 25% of them are in darkness. which seems a bit of a strange anomaly. You know, I'm not counting Antarctica as a landmass. I'm just talking about where people live. So where people live, for most of the time, for the majority of the time, is daylight everywhere.
And it's interesting that they just don't even bother to put anything on here that even remotely says the Arctic.
Mm.
There's no North Pole anymore. There's no, it's not on Google Maps. It's not on Google Earth. It's not on day and night, date, time and date. I don't see it anywhere anymore. No they've got the Arctic Circle, but that's it. There's no ice mass.
Yeah.
Called the North Pole. So
if the sun was a spotlight, as suggested by so many of the flat earthers on these circling suns around the AE map, then you wouldn't get that configuration of daylight. That is a sine wave.
Yeah.
And that is with some kind of magnetic interference.
Of course, there's somebody right now who's looking at this who's thinking, well, if I could just convert that, what does that look like when that's converted to an AE map? Well, go ahead and try. See what you come up with.
Yeah.
See if the sun can show a lighted up area of just in the center, but not only in the center. They get sun in Australia and South America and South Africa, and New Zealand. They get sun there. So on the AE map, the sun would never reach that far at all, close, even if when the sun is in the Tropic of Cancer.
Yeah. So, well, if you look at that map there, Laurie, you look where the sun is, and then you look right to the right-hand corner. The northeastern side of Siberia. Right. The sun there is a lot more than 6,000 miles away from it, isn't it? That's probably like, I don't know, 15,000 miles.
Sure.
And yet still daylight. Well, how can that be when you can, on the equator, you can only see the sun for 6,000 miles either side? There has to be some other explanation.
And the explanation, like we talked about last week and the week before that, possibly, is that it is bouncing off of the diamond barrier wall or the square northern wall or something in order for the light to be when the sun is in the Tropic of Cancer. Well, and people way up north in Sweden and northern Canada are seeing northern lights and seeing 24-hour light. They don't really call it sunlight; they just call it light. Go ahead.
If you look at if you look on the left-hand side on the sine wave, which is about it ends about a third of the way down, and then you look on the right-hand side, where one ends, the other would join up. It's seamless. This is evidence that the Earth has a seamless exchange between East and West.
Yeah.
The wave just continues, doesn't it?
Yeah. Yeah.
So people take
this is something for people to look at, to try to wrap your mind around, understanding the possibility of a 4D world where time is the fourth dimension, and that we are in time and space on, traveling on Earth. Each day there's a reason why it's a day. It's not just the traveling of the sun. So
that's it, yeah. And but so many flat earthers can't get their head around it because it's far too complicated. God wouldn't be able to make something that complicated. But I mean, come on, making the Earth itself is an act of magic, isn't it? Man, it's beyond the capacity of man as we know it to build something the size of the Earth. It'd be just how would you build an Earth? How could you do it? Literally, from scratch. You just couldn't do it, could you?
Well, no. And not only that, but, people try to wrap their mind around the Bible saying on the first day God did this and the second day God did that. You know, before there was a sun or a moon, which he didn't make until I believe the fourth day, there was a whole lot of stuff going on. Go read Genesis if you don't hear me. Before God created the sun and the moon, there was already earth and seas and grasses growing on the plains and so on and so forth before the sun came. So there was some kind of light for the things of earth to live under. I mean, grasses growing on the plain requires some kind of light in order for photosynthesis to occur. So, so anyway, what is a day before the sun and moon were created? People say, oh, well, maybe, you know, a day for God but during the creation period was 6,000 years. Where do you come up with that? Or 10,000 or a billion? Where do you come up with any arbitrary number for how long a day was before the sun and the moon came along to determine the length of a day? And so with regards to creating an earth, I mean, I'm a creative person, you know, I make art or build things or whatever, and I have a bunch of raw materials. Okay, I have some, if I'm going to build a birdhouse, okay, I have to have some wood and I have to have some nails and a hammer and some tools and some paint and a post to stick it on or a tree to nail it on or whatever. But I need those resources and those raw materials to actually make it manifest. I can see it in my head, but in order to manifest it, I have to have something to work with. Before there was anything, there had to be stuff to work with, had to be created first. You follow me? So, you know, this is a big deal. This is a major thing to try to wrap your head around. And it's one of the reasons why it was so easy for me as an individual once I started investigating the makeup of the belief system of the flat earth theory, so to speak. You know, that shit was all too simple. Okay. So once I started looking into that, I'm like, no, I don't think so. Here's a perfect example. The people who are Bible believers, who are not flat earthers, for example, okay? You have Bible believers who say that everything written in there is explaining everything. Okay. If it says in there that God stopped the sun for a day for a battle to be completed, for there still to be light to finish it, and yet you don't believe in flat earth because you don't see scripture that says that the earth is flat or backs it up, and then you know, how can God stop the sun from moving regardless of whether the earth is flat or round globe? If you are a believer, you have to take that information and put it into the mixture of all the other information to come up with, what is this saying? What is this describing? Okay. And if you're a glober and yet a Bible believer, it says God stopped the sun. According to the globe theory, everybody dies. I mean, we all go spinning off into nowhere, into the abyss, because because the earth can't stop. The sun can't stop without the earth stops spinning. In that theory, okay, you got to be able to take this thing apart piece by piece. So, if somebody can explain to me that God can make the sun stay stationary over a particular part of Earth for a day, or longer than a 24-hour period, then what happens to all the rest of the theory? Because none of the globe thing works. Now you can say, okay, well, but wait, I'm a geocentric. I believe that, the earth is a ball and everything's moving around over our heads. Okay, how does that work for all the clockworks that are all moving together all the time simultaneously to suddenly be stopped long enough for this battle to be completed, and then God just starts it all up again? What happens to the synchronicity of all of the other things that go along with the sun? So, you have to continue to ask these questions and compare notes of all of the information. You cannot cherry pick. All right, Lawrence. So what else you been dreaming up this week?
Well, I found something very interesting today, and I invite any of our listeners. Yeah, I'll bring you up in a second. I found this website called Pi Digits, and I'll just read the chat. I'll bring it up so you can see for yourself. It's
okay.
I'll bring the site up. Just bear with me, and I'll just read this little bit on it. And I found this fascinating. There's all sorts of stuff on here.
Making faces while you're doing
there we go.
Screen
so
share while you capture me.
This is a website called Pi Digits, Pi as in the mathematical pi digits. And then they've got all these sections down the left-hand side. I was looking at this one on levitation, and you're thinking, well, what's that got to do with the flat Earth? And I'll just read this bit out here. And it says, levitation has to do with temporarily blocking and redirecting the natural flow of electromagnetic currents, and pi has everything to do with levitation. Pi is the magnetic flow reversal point, also known as diamagnetic vortex point. Furthermore, an accurate pi number is a time lock for an exact timetable. These ideas are described in more detail in Calculations and Daniel's Day. So these are sections on there that you can look at it in more detail. And it says, imagine pi as the center of an hourglass, the point of image reversal in a lens, the point between two realities, i.e. the two realities on, you think about that on the Earth, the passage between east and west, the point of polarity reversal, or the point of end of time and new beginning. However, it only appears as a point from our perspective. Another way to describe it is by using the example of a propeller, with the center as the now and the tips on opposite ends of it as the past and the future playing out now. Maybe the reason why some people can glimpse past or future moments is that one prop tip touches the opposing moment or ripple in time briefly while rotating forward. So traveling through this tunnel or vortex of time to the point of reversal is sort of like passing through the center of an hourglass, coming from the opposite direction at the same time. So, this site is well worth a good dig around. There's that guy who got in America, who got those places where those stones would, those huge stones he could, I don't know, somewhere you've heard it, you've talked about it before, the Coral Castle, isn't it? And that guy.
Well, there is a place in Scotland, I believe. There were several places actually where they have erected what they call standing stones, and I've read quite a bit about that several years ago. Where one thing I read was actually a fiction novel, but the place is real that the fiction novel was written about. And the woman went from, believe somewhere like in the 1990s or something like that, back into maybe the 1500s, because she was standing at the standing stone when some time warp thing happened. And she found herself, hundreds of years in the past. So it was very interesting. The novel aspect of it made you think about if something like that happened, because if she was from modern time and she also happened to be a nurse, she understood penicillin, which hadn't been invented yet. She understood antibiotics and germs and the cellular level, which they had not discovered yet because they didn't have microscopes or whatever. Just sort of extrapolate that out. But the idea is that you know, these standing stones are erected at these electromagnetic ley lines, as they call it, and they're for the purpose of pagan witchcraft stuff that was going on way back then. So there's got to be a reason why they put them where they built them. And we talked last week about witching water and so on and so forth. It's all got to do with electromagnetism. So I like the idea of the hourglass. You're at the center of the hourglass where the sand is, passes from one globe part to the other, container to the other. And if passing through time, I also like the propeller idea that he used to describe that, for being able to just get glimpses of, for premonitions and things like that, because lots of people, nobody can argue that people have them. I've had many myself, premonitions that happened almost instantaneously before the event itself happened, like thinking about somebody, and then a few seconds later or even a few minutes later, my phone rings and the person's calling me that I was just thinking about, and I'm like, whoa, that's so weird. I haven't thought about you in a while. I mean, sorry to say that, but then you call me. It was that, ooh, did I just send some juju out there for you to think of me to call me, or did I sense the juju incoming that you were going to call me in a few minutes? You know what I'm saying?
Yeah, and it's like, when man builds one of these large tunnels that, covers a large distance underground, he always builds into it some exit points so that you can get out in a hurry if there's some kind of disaster in it. So you saw an evidence of that in The Fugitive with Harrison Ford, where, he went through some drains and he ended up jumping over the waterfall when, what's his name, came to get him. And you can imagine that the creator of this world we live in, there'll be some shortcuts in it as well. And those are evidenced in the Bermuda Triangle, where there's been lots of things just vanishing, and several instances of people, just flying along, and they're like 2 hours from Florida or wherever they're going near that area. And suddenly they lose, several hundred miles, and they find that they're at their destination with no explanation from it. So when Mark Sargent says there are no shortcuts on the flat earth, he's wrong, because there's evidence that there are shortcuts. We don't understand how they work, and we may never do, but you can actually, if you've got live examples of it, other than, sailing from east to west, which is as good as it's going to get, you've got ones in the middle as well, where people are turning up somewhere they shouldn't be, they would have to be flying at David Weiss speed to get time. They're in a little Cessna 200 mile an hour, and they work out they should have had to go 1,500 miles an hour to get from where they got to in the allotted time. And David Weiss is still sticking with his... So
because they can't, the flights probably don't exist anyway. So
yeah.
Well, okay, so let's extrapolate on that for a second with regards to the electromagnetic boundaries of this plane. For example, what if the so-called north and south are a barrier that you cannot penetrate, but east and west go on forever? Okay. So how does forever happen? Is forever because of time, or is forever because of a loop? In other words, we know we can't go back in time ever. No one's done it. No one's been able to do it. And as far as we know, you wouldn't know if someone had gone into the future, because if they'd gone into the future, they would already have changed the past, which is the now, which we wouldn't be able to. identify that anything was changed because it already was. It's one of those.
It's the Mandela effect here, Laurie, you know. But I mean, apparently the Germans designed some kind of time machine. I think they called it a looking glass. You might need to.
Yeah,
think
I've
one
heard of that. Yeah. Doesn't it have something to do with the bell?
Well, yeah, that was it. Yeah,
The bell.
Probably people having a good look at it, but it seems uncanny that the Illuminati, the Masons at the highest level, they seem to know what's coming in the future, almost to the extent that they've already been there and seen it happen, and they know what's going to happen. I mean, you've got your flat Earth card out there. I mean, back in whenever it was, 1984, when that board game came out, why would the
Well, I mean, okay, well, there could be this explanation that because the flat Earth had cropped up several times in the past and never actually ever truly went away from the time that, everybody thought it was flat. So I try very hard not to use a thinking method that is not based in any reality at all. I try to fit reality in with whatever I can speculate or whatever. But okay, so if forward and backward, east and west is then and now, okay, meaning the past is, since the sun comes up in the east, the past is the east, if you want to look at it that way, okay? And then the future would be the west, because that's the direction the sun's always going into. And since a day and time is based on the sun's movement and light, then so the east is the past and the west is the future. Since we can't travel faster than, since there really is no speed of light, light is now, okay, right? Since we know that the stars are not billions of miles away and light years and whatever they want to call it, everything that we're seeing is physically happening now, correct? I mean, if we go outside at night and we look up into the sky and we see the stars and we see constellations shaped in certain shapes that we've seen before, that's now, right? That's not a billion years ago and the light's just now getting to us. I mean, I never bought that shit from the time I was like that big. And so, okay, so if east is the past and west is the future, you can't go faster than time to go back into the past. That's what the whole time machine thing is based on, isn't it?
Well, I don't know. I mean, it depends on.
Is it based on speed, or is it based on cutting through a wormhole? Or, I mean, I've seen every kind of idea about it.
Well, if you look to the movies, there was a Star Trek movie where the opening scenes are the whole place is being flooded and it just keeps raining and it's a major catastrophe. And it's down to the whales. So Captain Kirk goes back into the past to bring a whale back to the future, and to travel in time. What the Starship Enterprise did a slingshot around the sun. Now, we don't really know how far the sun away is. And I mean, I don't think any flat earthers have actually done any real experiments to measure the distance. But let's say, for argument's sake, that you could do a slingshot around the sun. If it's within the firmament, then maybe you could. And if they could do that, then maybe they could travel into the future, find out what's going on, and then do a slingshot back around the other way to come back to the present day. And then they've got an idea what's happening in the future, and they could try and influence events to bring about the future that they want, rather than the future that beholds us if nothing else happens.
Well, I mean, there's people who would argue that, that's probably possible, likely, perhaps happened with regards to this Mandela effect, that suddenly it seemed like everything on Earth was just sort of going along, and everything was just fine and going along, not wonderful, not horrible, but about the same, just slowly progressing. And then all of a sudden, kind of since 9/11, as just if for an arbitrary earmark, it seems that things have really gone downhill fast, and that the powers that be, whatever you call them, the Decepticons, the Illuminati, the Masons, the fallen angels, whatever you call them, kind of got a little stronger hold on what's going on control-wise of the Earth and the systems and this whole kind of imminent new world order, one world government, blah, blah. Perhaps something they did alter something. Maybe there was a CERN and a wormhole and a blah, blah, Stargate, who knows? So if that's the case, then that is so way beyond normal human capabilities that what the hell would we be able to do about it anyway if they did that, right?
Yeah.
I mean, we just have to live with that and then, or not, or, figure out who the bad guy is and just go get him and lock him away or string him up, whatever it is you do with bad, really, really, really bad controller guys now. But let's just say, for example, that you can't go fast enough to go backwards in time much. I posted last week a picture that I took with had taken with Chuck Yeager back in, I believe it was 93 or 95 at some event that I went to where he was there, and I got my picture taken with him and met him and talked to him just very briefly because a lot of other people wanted to talk to him. And so I in talking to him and just watching him, I'm thinking, this is the guy who broke the sound barrier for the first time. And imagine getting in this plane that was sort of strapped to the belly of another plane and going up pretty high, excuse me, and being released. The plane you're in just gets dropped and you take off, and you don't really, because nobody's ever done it before, you don't really know what's going to happen when you break the sound barrier. I mean, you don't know if your eardrums are going to blow out or if your skin's going to implode, or, you just don't know. And so that was a rather heroic thing that he did, don't you think, for him to do that? No one's ever said that they have broken the light barrier yet, although that's one of those things that they show you in shows like Star Trek. Let's go into warp speed, Scotty, and advance light years into, over here to the other side of the galaxy.
Yeah,
you just don't know.
I mean, you get these. Sometimes you get these random thoughts, Laurie, and you just try and work out how things actually work. And you think the same as I do, that the thoughts that we have don't originate in our head. Our heads are just the receiving channel from thoughts that are somewhere out in the ether or on the backside of the moon. God knows where all the thoughts come from, but that they just come into your head, and we're just the receiver, and we express them by speaking. And it makes me wonder, are all these thoughts that's ever been, are they all just sort of swimming willy-nilly in the atmosphere, or are they in some kind of organized computer data bank somewhere that we can tap into if we become more spiritually aware or whatever? But
Or, are these thoughts being assigned to us? Think about it that way, not as a random willy-nilly thing, but that there is, even if you just think of it as a giant computer database, and the algorithms in this computer says, well, we need this to happen later, in order for that to happen, we have to do a flow chart backward and figure out what we need to make happen for that outcome to happen then. Okay.
Yeah.
And then we have to make these things, all of these things have to fall into place. There was a great movie that was made like that, where this genius guy came up with all kinds of scenarios that had to happen in order for a specific thing to happen at a specific time, and made it all happen. Like this cup had to fall over, which made that person look over there, and and the pencil fell down, and like kind of like what's the guy that does all of the things, the dominoes and the falling and all that. So perhaps that thought is literally wired to go, it's put in Lawrence's particular nerve channel pickup system, so that he thinks it. And then, because I mean, look, how many times in history have we been told that, oh, well, so-and-so said they invented the light bulb, but then so-and-so also invented the light bulb. These two people didn't know each other, and they came at it from kind of two different ways, but they both invented it, or electricity, or whatever it may be. Okay. The chance of that randomly happening at the same time in history. I mean, I just watched a documentary where what was the guy that Colt and Wesson, or Smith and Wesson, or whatever, two different guys came up with handgun type ways for multiple bullets to shoot one after another right at the same time. So I don't think, I mean, to me, it's not just some random willy-nilly thing. I think we make choices based on the information that, is sent down our particular fiber optic cable from the mothership or motherboard or God, whatever way you like to think it. So, the fact that you and I hooked up to do this show in the first place, the chances of that are infinitesimal. It wouldn't have happened, okay? Unless something, I mean, you live in UK, I live in US. We weren't really friendly friends on Facebook that much, just in a similar environment in a group, so on and so forth. But something made you think of me, and when you asked me to do a show, something made me say, okay, I mean, I don't know this guy from a load of coal, but I'll give it a shot. And since then, how many times have you and I brainstormed and come up with, I just happened to say something that probably meant nothing to anything else, but it just went ding, ding, ding in your head, that connected it to something else you were thinking. And that's the way synchronicity works all the time throughout history and humanity and people.
That's it. I mean, so you have a thought, and I say to myself, why am I having this thought? It's crazy, and then you start just going off at a complete tangent from what you would normally doing that day. And many times it actually leads to you finding something out that you without that random thought, or what you perceived as a random thought, you'd have never found it out. But I mean, if you imagine that radio waves and internet waves and mobile phones, all these signals are all surrounding us now, but they're outside our range of vision. And the same would apply to thoughts. Thoughts are, if we could see thoughts, you could see them coming into your head and maybe going out of your head. That'll be
or stopping them before they get there. No, I don't want that thought.
Well, when I was living in Anglesey, I remember one day, it was a beautiful day, and it's downhill down to the beach, and I used to walk down with my dog every day. And one day I was walking down, and I could see all these beautiful lines, beautiful shades of purple and orange and green all across my line of vision. And I saw them for the best part of an hour. And I just couldn't believe what I was seeing. I've never seen it again since, and it was like I'd tapped into something which I couldn't explain, but it was really freaky. I've got something else to show you.
What else about atmospheric conditions and every other kind of thing? I mean, you know, I've had a similar experience where I was staying in a condo that was a high rise, and it was summertime. And in summertime in Sarasota, Florida, all of the people of money leave and go to their northern homes. So you can be in a high rise condo and probably be the only, in the summertime, and probably be the only person there except for the workers. And so I was invited to stay in it. And so I'm in the pool by myself. There was nobody else in the building, so none of the other residents were at the pool. So I'm just like, woohoo, this is awesome. It's right out on Lido Beach. I'm sitting in the pool, and that same thing happened. Weird vortexes of weird waves. I mean, I thought I was sort of like getting overheated, or something, and my brain was frying out a little bit. But it was probably one of the most blissful moments I've experienced in my life, as far as my mind wasn't thinking of anything else, and I was like, no worries and everything. I mean, for that brief moment. So I kind of can relate to what you're talking about.
Yeah, and one thing that always puzzles me is that the elite of the planet, the ones that own 99% of all the wealth, they don't need us anymore. They don't need those billions or however many humans that there are, but we're all still here. And, you know, when they said in the Matrix that they were feeding off us for some kind of energy, there's a lot of evidence out there that they do feed off negative emotions.
This sucks, because I love what you're saying right now, but your sound is doing that breakup thing like it does right about this time every time. So you get out, you get right back.
All right, just a minute.
I can't be the only one that was hearing it, so I don't want the audio to be all screwed up. Now it's feedbacking through him and everything. Okay, that'll be better, folks. Please stay with us as soon as he comes back. It just seems to happen about every one of these hangouts we do right about this time. So what Lawrence is talking about, many people think of as being sort of, you know, woohoo esoteric or something, but it is definitely the human situation. Okay.
Sorry. Right, on the back now. So, yeah, what I was saying was that for hundreds of years, you know, or for as long as man can remember, they've always been in conflict with wars, and this side versus that side, animosity, and, you know, people in conflict with each other everywhere, even in their day-to-day lives. And the powers that be could end all that tomorrow if they could make the world a beautiful place and lovely place to live, and everybody'd have enough to eat and clean water and, you know, lots of leisure time. But they choose not to. They choose for us to remain in conflict on a permanent basis. And if we're not getting enough conflict, they'll invent some and they'll start a war, and they'll always have left versus right. And if you look at the animosity in flat Earth versus ball Earth, and flat Earth within it, they're generating a whole lot of bad emotions out there. There's so much ill feeling in this subject that it makes me think that they're actually feeding off us. If you look at a football match, for example, yeah, you've got opposing sides, you know, and there's a lot of hatred at football in the UK. If you go to them, you know, they literally hate each other. And some of the football matches that, you know, that I used to go to, I didn't get involved with it. People would go specifically to start fights with the opposing side. They weren't interested in the football. They just wanted to kick shit out of the, you know, the opposing fans, you know, even if they'd never met them personally. And I had this random thought this week. Let me show you this. There we go. Entire screen, share. And this probably doesn't mean anything, but it might mean something to somebody. Let's have a look. Where's that gone?
I don't know. Right now you're showing me.
All right. Well, just a minute.
You always hit the screen share before you have the thing there that you want to actually share. So you need to have the thing open first before you hit the screen share button.
Have I got it now?
There you go.
Right. So I just had this thing about, what was the biggest sport in America? And I thought, I was thinking about the negative energies. And I know in your country, I don't think they have the, everything's peaceful and everybody drinks beer and eats popcorn and hot dogs. And
Go ahead.
But if you look at that pitch, the actual small place that they actually play on, the boundaries of that where they run round it, it's a diamond shape, just like the Earth, surrounded by a crowd of people with conflicting. I don't know whether one side goes on one side and one on the other. I don't know. And then you look at the grass that surrounds the entire pitch. All the grasses is cut in a specific manner so that they're all diamonds. Now, I don't know whether there's any significance in this, but it may well generate some kind of energy. You've got the energy of the crowd and in a little amphitheatre. It may generate some kind of, resource that these people, because they say we're useless eaters, don't they? But they must want us for something, and maybe it's the negative emotions that the human race generate.
Well, I mean, there is possibility with that, that whole thing, because the people do sit, for the most part, whichever dugout your particular team that you're rooting for is on, that's the side you sit on. And, people do the wave and all of these kind of things where they coordinate together. But I mean, you can imagine how it would be like if guy for team A was sitting right in the midst of the entire crowd of team B and started going, kill the bastard, saying a bunch of shitty things about whoever's pitching at the moment. So you kind of don't do that, but it isn't that peaceful. It is if nobody stirs up any crap like that. But it's interesting that you mentioned about the diamond, because that's the way the ley lines supposedly lay out on the globe, and so they would have to lay out similarly on the flat Earth, because we know that the globe is created from the flat Earth, not the other way around. So I don't know. I definitely think that there is a lot to be said for the negative energy associated with pain and suffering and unhappiness and all of the other things that go with it, homelessness, being hungry. I mean, any of the negative, as long as a human isn't happy, they're usually, most people aren't somewhere in the middle. They're one or the other. They're happy or they're unhappy. And I definitely think that, just this past week, there was the shooting, so-called, that happened in Orlando at the gay club. And I'm not going to make any commentary whatsoever as to whether I believe this event was staged or a false flag or anything like that, because that's not the point of why I even bring it up. But think about the news stations in the United States were completely inundated and flooded with this event, the reporting and the news and the interviews of the people that were there and the witnesses and the parents and the families and all of it. And the gay community and all of the president down to the Congress, anybody had to chime in and give their opinion about it. Well, that's a hell of a lot of negative energy created.
Yeah, I know, and you've got all the, more so in your country, but also in ours. That, I mean, everybody's stressed, aren't they? Because now, if you went back to the 1950s, the man could go out to work and his wife could stay at home and raise the kids, and it was, relatively a leisurely lifestyle. And now you've got people, some have got 2 or 3 jobs, and they're forced to do that in order to meet, the cost of living and everything else like that. It must be creating so much stress for people in their lives. They just don't get to.
It's unbelievable.
And if you look at the word emotion, well, motion means movement, doesn't it? What does the E stand for in emotion? What does the E stand for? Does that mean energy?
Probably.
What does it mean?
E, energy, motion. Yeah.
Is it anything to do with
probably
the E?
The root of the word.
Because I think emotions are what our purpose is for those that control us, and we are being farmed for our negative emotions. So in that respect, when we
that's
say
the matrix,
we don't want the kumbaya and everybody to love each other, maybe that's the last thing that they want. If everybody did that and all the negative emotions went and everything was positive, maybe things would work out better. But
or maybe they'd have a reason to just finish us off and say, these guys are totally useless eaters because we can't eat off their energy anymore.
We need some more wars. We need some.
Yeah, well, I mean, think about it. It's not even just wars. The wars affect the people that are having the war in their country. Yes. Does it affect the people of the country that's doing the attacking, like the United States, for example? No, except for the people who have sons and daughters and family involved in the war. But I mean, I remember growing up, it was actually taught in school as far as sort of a lesson in economics that, war is good for the economy, puts people to work, creates, factory jobs and so on and so forth. I mean, and they go back and remark about World War II and how much, people were put to work, and they'll show you pictures of full-flung factories that came out of nowhere and is all of a sudden making airplane parts. And all of a sudden, they were retrofitting this, washing machine factory to make, wrappings for what's it called, the part that goes around the outside of the airplane, and women sitting down went to work in the factories making uniforms or sewing soles on shoes or whatever it was, and that sort of came not that far on the heels of us living in a really bad time during the Depression, and it just had come out of it, and it's actually credit the end of the Depression on getting involved in World War II. So they glorify the whole war thing. I don't know. All you got to do is watch the YouTube video called "All Wars Are Bankers' Wars," and you can pretty much get all of that in explained pretty simply.
Yeah, I know. I think we're probably instinctively quite a war-like race, but when somebody really pisses you off, your instinctive reaction is to call them a dumb arse or what. You're going to react in that way. And when you do that, like you're driving your car down the road and somebody cuts you up, and you say, "You fucking cunt, you've chopped me up," and you're raging and you're gripping the steering wheel and you're getting really angry. Well, all that anger that you're pushing out, that's going to go out into the world. Maybe the driver that you're focusing it on, he's going to feel that, and he'll get to the office that day and he'll start taking it out on his staff because he's had a bad day, and it sort of makes a bit of a wave or a chain reaction of how life goes. And
the same thing happens in reverse when something wonderful happens.
Yeah.
I tell this story years and years ago. One of my first careers was I was a hairdresser and a salon owner. And I got involved in cutting hair when I was in high school when people all had long hair and everybody started getting a shag haircut or something cool. And I just innately knew how to do it for some reason. And then people said, well, why don't you go get your license and do this for a living? And so I did, for lack of anything else fun to do. And then I got into owning salons and stuff. My point in telling the story is I did that for 16 years. And every weekend, it seemed like I would go through this emotional roller coaster when it would be something like, let's say Saturday morning, I would come in and I would be doing a wedding party. Okay. All of the women from the wedding party were all coming in to get the fancy hairdos for the wedding party, for the wedding. And, I would get done with that. And then maybe some guy in his 50s would come in and say, boy, it really sucks. I'm going through a divorce. And you'd sit there and listen to the, horrifying story of his horrible wife and whatever was going on. And then the next thing somebody comes in, it's a teenager and they're going to a dance, and now you're back up again. And then the next thing somebody's coming in and they're burying their mother tonight or tomorrow, and they need to get spruced up. So your emotions go up and down with the people that you're dealing with all day long. And by the end of the day, there were times, the people you didn't like, but you had to do their hair anyway because, that's what you do. It's your living. By the end of the day, you would be emotionally worn out with all of that energy and having to be nice, and you're watching and you're doing, and you're looking in the mirror and watching the whole thing in reverse and thinking, I wish really I could just put my headphones on and listen to some really great music and get really creative and do what I do and not have to listen to this shit. Here, have a magazine, And so I can imagine what a lot of people go through that have to go in and work with people all day long that they don't enjoy working around. It's some numbnuts at the office that's just a creep. Or doctors or lawyers or anybody, it's going through all the emotional stuff that goes with their clients. I mean, it's just the whole world's like that now.
Yeah, I know. And it's funny with life.
Leave your camera up. We're looking at your neck.
Sorry, I'll show you something in a minute. It's funny with life where I quite often turn a negative into a positive. So I get very few complaints with the job, my own little business that I do. And when somebody does complain, I'll take the positive out of it. So somebody said they didn't like one of my oils. I sell about 150 different types of essential oil. So I thought, right, well, I'll look into the market and I'll expand the range and get some different sorts of that particular oil. And I had a case recently. There wasn't somebody complaining. Somebody contacted me and said, I work in mental health care, looking after people with mental illnesses, and all my staff are stressed to hell. Can you design an oil for me, a blend of oils that helps with stress and anxiety? So I came up with an oil for them, and they never came back to me. So I thought, well, I've made it now. So I listed it on eBay where I sell my oils, and that became one of my best-selling blends.
Well, I was going to say, you should be a billionaire if you come up with a formula for oil de-stressing.
There's all sorts of blends out there. So I had a woman yesterday who contacted me, on Friday. She had bad migraine headaches, and she'd looked up a blend with one of the very expensive, I think it's Young Living over in America, and they charge you extortionate price for an essential oil. And she gave me the blend, and she says, can you make this one up for me? So I did, and I sent it to her, and she sent me a very nice letter today saying, thanks ever so much. It smells wonderful. I've had it in my diffuser, and I've put the oil on my two temples, and my headache's gone. So I thought, right, well, I'm going to add that to my list. So I've got it. So I helped her out because I didn't make hardly any money out of it because, because
Not always about being able to make money off of it.
Oh, I know. Well, that's why I don't think of it that way. So anyway, she's come back and given me all this positive feedback on this blend. So I've got another one to add to my list. So it's the more good. Whatever good you do, it comes back in spades and rewards you. So I give lots of stuff away, and people think I'm crazy. But the more you give away, the more you get. It's like
absolutely true. I found the same thing with my business too, Lawrence.
You just cannot give things away. If you think you've given something away, you haven't, because whatever you're giving to yourself ultimately, and it comes back, and you're giving me all these free oils. But then they remain as a customer and come back and buy even more,
right.
and then I'm making money out of it. But that isn't the main objective. It's it's as much about survival as anything else, isn't it? So if you're going to work, if you're caught in a 9 to 5 job doing something that you hate, then decide what you want to do and just do it, and the universe will find a way. If you're passionate about it and you get good at it, if you do anything long enough and learn from your mistakes, then you will get good at it, and you will be able to earn a living at doing anything you want to if you have a passion for it. Well, obviously,
that absolutely is true. I can testify to that myself. I mean, you couldn't have said that any more clear, because I've found the same thing to come to pass.
Yeah, and I think
and I also have done the opposite with what you did. I've had people who really want my services or what I do, and I don't really like the people. I don't think they're good people. They don't have good energy. They suck energy off of you, and I don't have them as clients. I don't just say no, I won't work for you, but I come up with all kinds of reasons why this is not going to work out. And I'm better for it, even if I can have to eat cheap lettuce instead of top quality lettuce. I'm still eating, but boy, I tell you what, I mean, I've had people that they have more money than God, and they want to hire you to do something, but they're just buttheads. And I made up my mind a long time ago. I don't have to do anything I don't want to do. And if the energy part of it doesn't feel right, and if I'm not getting a positive emotional feedback from it, damn the money. The money, I can do all kinds of things for money. But if I'm going to make money anyway, I'm going to choose where it comes from and how what I do to get it. So
yeah, and that's the thing with most people. The majority of people, they become institutionalized with what they do, and they'll do the same thing or something similar for their entire life. There's not that many people who just say, well, I've had it, I just don't want to do this anymore. I want to do something I really want to do. And I've done a couple of changes in my life where, I was in a job for 18 years and that was it. I just jacked it in. I applied for every single job in the paper when you used to get jobs out of the paper. And I thought the first one that comes in, I'm going to trust to the universe, and whatever that job is, I'm going to do it. And that's what. And then I got into another job for another 15 years, and then I decided to get out of that and ended up doing what I'm doing now. But you can, your thoughts will become reality if you focus on them enough and write it down.
Yeah, sometimes not only sometimes, most of the time, we cause our own unhappiness by forcing our own will into the universe or into the equation, instead of letting the right thing that's programmed along to do that. And so, I've had times where, I just really wanted to do something. I mean, a few years ago, I just really wanted to open an art gallery, and I did. I mean, I found the money. I found this great space. It was in an up and coming little neighborhood, or so they said. It was in 2009. We were supposed to be going through an economic recovery, and I live in a city where there's plenty of money for people to buy nice, original art. All of the things seemed to be in line, except I wasn't supposed to be a shopkeeper. I've never been supposed to be a shopkeeper. And I didn't have that part factored into the equation, meaning when immediately the thing wasn't profitable enough for me to hire somebody to run it, to sit there day after day after day and talk to all the nice people coming in to buy the art, not. And I had to be the one to do that. Well, now I don't get to make art anymore because I'm too tired when I get home because I've been selling art all day or talking to people about art all day. And I'm ending up being a shopkeeper. And that's not what I wanted. And I've been down this road enough times in my life that I've had success at doing something, but I still wasn't happy. Success does not equate to happiness. That yes. I literally said, no, I don't want to do this anymore. And you know what? I don't have to. I can do something else just as easily as I can do this. And so I'm done. And, after 16 years in the hair business, I had a very lucrative hair salon with multiple people working for me and in a great location on Main Street and so on and so forth. And I just said, enough, I'm done. And as a matter of fact, one of the things that made me say I'm done was a guy came in, he was 18 years old, he was going off to college, and I had given him his first haircut when he was 2. And I thought, this is it. I'm sure there's something else I can do with my life than repeat this year after year after year. And that was sort of one of those triggers that said, shit. I gave this kid his first haircut. I can remember him sitting on the little booster seat in my chair and thinking I'm going to cut this kid's ear off if he doesn't quit wiggling around because I don't do kids' hair. And then, he tells me this is my last haircut I'm going to get from you until I come back from school next summer because I'm going off to college. And it was just like, ding, 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 ding. That was one of those time for a change things. So, yeah, the whole flat earth thing has even been a familiar sort of path that a lot of the other things that I've done in my life, this flat earth thing is sort of taking the same path as some of the other decisions I've made on things that I pursue or follow. And at the beginning, I was very passionate about learning all this stuff about the flat earth and about the earth I live on and my home and so on. And then suddenly something turned and I realized, I'm not really contributing anything to the future of this. I'm just a part of it. I'm just, coasting along and learning all the things we're supposed to learn as flat earthers, which goes back to your curvature calculation thing at the beginning of the show. I got that real quick. Oh yeah, I get this. And I got it after I questioned a bunch of people who I said, is this correct? Can I repeat this in good conscience to people who are just finding out about flat earth? So where'd you go, Lawrence? He just left. He does that. You guys at home probably don't know that happens sometimes, but I'll just be talking along and Lawrence goes, oh, I can sense Lori's just going to rattle on for a while here. This is a good time to go cut and get a cup of coffee.
Well, yeah. And it's funny, isn't it? Because I think the growth in flat earth awareness, it does need to be more organic at an individual level. And there's lots of flat earthers out there. And I put a question on the page today about the silent majority, a few days ago, about the silent majority in flat earth who just observe and take it all in, but they never say anything or do anything. And their friends don't know they're a flat earther. Their family don't know. None of their Facebook friends don't know anyway. Because I look at some of their pages and and there's nothing to indicate that they were a flat earther. Whereas others, I mean, some get loads of leaflets and flyers and flat earth sticky tape. People may laugh at it, but if people keep seeing it every day, you know, they walk past some sticky tape that says the earth is flat, some of them are actually going to go and Google it and see what happens.
Right.
One of the things that I do is for birthdays and even for people I don't know, I give them free fragrances. So you've got one here. This is Napoleon's cologne, and it's called It's Flat Man. Yeah. So I've got various fragrances, and they all have a flat earth theme. That one's called Flat Earth Fragrance Summer Cologne. Ain't no gravity.
Well, that's where I was going with my story when I realized you were gone. I was talking to Air. Was, you know, when I realized things sort of went flat with flat Earth, with me anyway, and that I had kind of learned everything all the dogma that I was supposed to learn and regurgitate to others. Then it suddenly dawned on me that, you know, there has to be more than this, and I don't have to stand out, but I have to be important to myself in my quest in this flat earth thing. I can't just be another go along to get along person. And I've always been pretty comfortable being on the fringe of things and being, you know, somebody who questions everything. And so I kept questioning everything. And that's when you came along, which kind of tells me we were meant to question it together. And if nothing else, you know, I'm confident to be the Ed McMahon to your Johnny Carson, or vice versa, whatever you want to call it. If it helps you state some of the things that you're thinking about, it helps me to brainstorm with the information that you're adding in to what I already know and am thinking about. So you know, I'm completely confident in saying the earth is flat. If somebody gets all wigged out on my Facebook page, and which started happening at the beginning, but it doesn't happen anymore. I mean, people don't even challenge me anymore because it's been over a year and I'm still doing it. I'm still talking about it, posting about it. They've either gone away or just unfollowed me, maybe, or just go, you know, thinking, well, this is a phase she's into right now. She'll get out of it soon enough. So, you know, all I can say is thank you, Lawrence, for, you know, helping me. And I hope that I've been helpful to you on this path of discovery, because it's not the flat earth information and research and digging into things should never end. As far as I'm concerned, there will be no end to it.
Yeah, I know. Well, if you hadn't been there to do this show, then I'd have probably walked away from it, because, you know, I was just getting so angry with the way it was going, you know, with the little clicky groups that pop up on each other's shows and just keep recycling the same information, much of which is not true. So our role is to, you know, find out what we've been told and see which of it is true, and if we can find stuff that's not true, then expose it for what it is. And we'll get a lot of heat from it, you know. But more and more people are coming to accept that the AE map is total tosh. You know, when I first started raising it as a problem, I was on a lot of flat Earth pages, and I was getting so much stick about, you know, me point. Same as with flat Earth, because when I'd started doing flat Earth, there weren't any flat Earthers. There was none. There wasn't a single group on Facebook apart from the official Flat Earth Society. That's all there was, and I got so much grief, you know. And then it's gone the other way now, so that I don't get grief off ballers, or occasionally I do. The grief is from other flat earthers who want to hold on to the established.
I can testify to that too. I'm getting more shit from inside the flat earth camps than I do from globe heads or ballers or whatever you want to call them, because most of the ballers just like, whatever, but the people in the flat earth community, once you start, they're always the ones that are quick to jump on everybody else like ballers and say, ooh, cognitive dissonance, your cognitive dissonance is kicking in. Okay. But if you say something anti flat earth dogma, their cognitive dissonance kicks in and they start getting mad and say, what are you talking about? That's the most ridiculous thing I've ever heard. And you're like, did you even ask me one single question? Did you even look at the video? Have you even investigated what I'm talking about? No, I don't need to, because you're wrong.
Yeah, and anybody who's watching, we're going to get all sorts of comments on the video tonight. You probably delete the crackpots.
Oh yeah, thanks a lot for that, Lawrence, because I'm the one that has to go through and kick out all the asshole comments. Yes, and by the way, I do have the comments set on approved, and if it's if it's intelligent at all, it goes through. But if it's just a troll or somebody calling us idiots or whatever, no, sorry, your comment's not going to get on that.
Yeah, and of course we don't know who actually watches this program, but some of the the brighter flat earthers do watch us, because we actually talk about real things and different things, and we're not restricted to the established model of the flat earth and all that goes with it,
or the social aspect of it.
Yeah, so because what's his name, Event Skeptic, I listened to his show. I've re-listened to it all again, and these two guys who he was trying to introduce the new model to them, and he was getting so much negative stuff because these people had already decided that they knew how it was, and they didn't want to unlearn what they'd already learned or taught themselves, because it's like they felt it was undermining them, and they wanted to stick with what they've got. Whereas, if somebody comes on with a better model than what we've come up with, then and it makes sense, then I'll go with it. So if you watch the show tonight, then you know that the curvature figures that you've given are incorrect, unless the size of the globe is incorrect. Then it would all change again anyway. But the average,
or unless you're standing on the North Pole.
Yeah, the average curvature on the globe is just under 2/3 of a mile per mile. So this 8 inches per mile squared is rubbish, and stop using it. Brian Mullen, if you're watching it, stop using the 8 inches to mile squared. You're a clever guy in terms of conventional science and engineering and physics, but you're not clever in terms of interpreting reality, and what you're showing is not reality, because we don't live at the North Pole. We live in other places where the land is steeper, and it would not be possible to live normally if you're living on a slope that's 60 or 70 degrees. It just
unless you're a goat.
Unless you're a goat, yeah. Yeah.
So, I like Brian. Don't get me wrong at all. Don't lump me in with Lawrence, because Lawrence is a little harsher than I am about a lot of people. I have actually met Brian. Brian was there the day I filmed the Red Boat video, and he is a very, very nice guy, and is very, very bright, very articulate, and has a gift with explaining things that he's trying to show you. But if he hasn't looked at this concept of where you are on the ball would be related to what angle of the dangle you'd be looking at, then I would love to hear a feedback from him or anybody else who is a math person or anybody architectural, all this kind of stuff. Somebody who has the mind to be able to test what Lawrence is saying and rebut it or debunk it, because if he's off on the wrong path, if this is a tangent that is absolutely erroneous, then show us why and show us how. We stand that way on every single question we ask about not only the globe, but about the flat Earth theory and flat Earth dogma. So it shouldn't become dogma unless it's provable, testable, and observable. So that's all that I got to say about that. So yeah, thanks for being patient, Lawrence, and explaining it, at least from your perspective. And if anybody gets mad watching it, ask yourself why you're getting mad. Because you got fooled by the globe bunch, or because you got fooled by the flat Earth community and whoever set in play the 8 inches squared per mile squared thing. Decide who you should be focusing your anger on. Should it be us, or should it be yourself or somebody else that's told you a lie?
Well, yeah, I know, and it was us who, it was Free Energy who brought the concept, but it was us who brought Pac-Man feature to the masses, and people still laugh at it because they haven't looked at it. And the same thing applies to the globe. Unless you're at the North Pole, you're going to have great difficulty standing. I remember going to one of these big swimming pools in somewhere in Spain or somewhere, or one of the islands. And in the middle of the swimming pool, there was a big sphere with water coming out the top. And you could stand on the top, but to get on it, you had to climb up these ropes. And believe me, you could not walk all over the sphere. You'd get so far down, and then you'd fall off. It's just, gravity was not keeping me pinned to that sphere in the swimming pool. You could just walk about on the top, and as soon as it got too steep, you're going to fall in. And that's what would happen on a globe if we actually lived on it. There'd be, a few goats and a few Eskimos on the top, and that would be it. The rest of it.
If you just even take gravity as an example, if you live at the equator, the greatest pull of gravity on your body would be you laying on your side, because there's more surface area. You laying on your side than you standing on your feet, right? So everybody would be stuck on their side to gravity, to the earth. It would take an extra amount of effort to hold yourself upright on your feet. I mean, there's just so many of those kinds of things that once you really start thinking about it, it's kind of like the flat earth in theory in general. Once you first heard about it, you just were like, no. Almost everybody was, no, this is crazy. Until you heard your first thing that went ding, ding, ding. Now that clicks. That makes sense. And then you added another thing and another thing and another thing. And then now you call yourself a flat earth researcher, okay, or a no baller, or some version along the way. So, I'm a full-on flat earther. I believe I live on a flat plane. Do I know the perimeter? No. It feels probably closest to me to be some kind of a sideways twisted diamond with a pyramid over the top of it, or something like that. But whatever it is, the outside shape is still forming, because I'm still testing data against it, or trying to come up with as much data as I can to form a hypothesis. You got the ball.
And I think that those people that are doing experiments on curvature, it's a waste of time, because if we really lived on a globe, the curvature would be evident to all. So many people say, yeah, but the curvature itself is so gradual that you wouldn't notice it. And you won't notice the curvature much. It'll be very slight, but you will notice the fall in elevation. So take a
I
look
can't
at.
wait for the screen capture of you holding that ball up against your head that has somebody makes a meme out of that, you know, Lawrence has gone baller.
you, you know, but that is it. But so many people are doing these curvature experiments. Even Jerem was doing it, and Matrix Decode's done it, and there's lots of people doing it. You know, and showing the, you know, pictures of Google Earth and saying what it would be over this distance, and they're using the wrong equation. So, you know, it will be possible to somebody. If I don't do it, then somebody will do a little Excel spreadsheet where you can tap in the latitude of where you live, and that will give you the curvature per mile in your locality as to what it should be. But you don't really need to do that. Take a look at the globe, see where you are, yeah, and you'll see what the fall away in land for it. So curvature itself, yeah, it is very gradual, but the fall in elevation is so bad in certain places that you couldn't live there. And that's what you need to get your head around, because this is what hasn't been talked about. And this is the most obvious feature of why we don't live on a sphere, because everywhere's flat. And if you lived on a ball, it ain't flat anywhere apart from on the top. And we don't live on the top.
Holy crap, Lawrence. Look at the, put Australia to the camera. Australia's huge on that ball.
Yeah.
Look at the size of that.
This is it's actually quite good, this is. It's a children's globe, and it's got lots of little tiny islands on, all named, and it's got the international date line, and then it's got the capitals of all the countries on. So, you know, maybe if you want to know your geography. And my geography has improved no end since it's got into flat.
Mine too.
You know,
and yours is 10 times what mine is, because, you know, you did the map with the distances from city to city by plane flights. So that really ingrained it in your head.
You look at a place like Kazakhstan, for example. Yeah, Kazakhstan is half the size of North America. But with most probably Americans and Britons, if you ask them where Kazakhstan is, they wouldn't know. But it's right smack.
Yeah, they would just say, "Oh, you know, it's one of the stands over there." You know, Uzbekistan and the stands.
And Mongolia, you know, these places. And then you've got these places in the far north of Canada and Siberia where there's absolutely nothing there. There's, you know, you look on the maps and there's nothing there. There's a few coastal places, but the rest of it, there's just nothing there. I don't think anybody lives there apart from a few remote sheep herders. And I guess,
well, I mean, a lot of the places on Earth that, you know, people do live at now, you know, if you think about how far they've migrated from the so-called beginning place, according to the gods of Egypt, it was Egypt, and which is where everything started, at the mouth of the Nile. But, you know, what would, at this day and age, what would possess someone to continue to want to live in some of these most inhospitable places when there's plenty of other places for them to live? I mean, these desert people and the people that live in, you know, northern Alaska or Patagonia, I don't know. I mean, just extreme places. I can't imagine of all the places that you could choose to live on Earth that you would pick one, you know, remain in one of those.
Yeah, and that's another thing on the globe. So if you look where Egypt is, it's a similar latitude to you, Laurie. You know, it's about 30 degrees north. I think you're a little bit further south than that.
27.33. I just looked it up.
Yeah, one of the first things because you get all these flat Earth facts, and one of them was like the Nile. I don't know how long the Nile is. It's maybe 1,000 miles long or something like that. But it actually only falls something like a foot over the entire length. Yet when you start taking the falling elevation into account, the Nile should fall maybe, you know, 600 or 700 miles over its length when you take into account the falling elevation. So there's more evidence that we ain't on this spinning.
Well, and how many of these rivers flow backwards?
Yeah.
You know? All right, so we're at 3 hours. I can't
Okay.
believe we did this again. I mean, we just can. So thank you so much for all of your hard work, and we'll see how this curvature calculation flies in the face of 8 inches per mile squared, which is really easy math. This one you got to do a little more work, but we'll see how this flies in the community, and
yeah,
I'll see you next Saturday. We're going to switch to Saturday from now on, right?
the new figure is, if you want the curvature figure, till we've got per latitude, the average is 3,358 feet per mile. Yeah, not 8 inches per mile, not 8 inches per mile squared. 3,358 feet per mile. So suck up on that.
Love you, Lawrence. See you next Saturday.
By the way, if Ronnie, if you're watching, can you send Laurie your email if you want to come on the next show? Because we'd love to talk to you and expand on what you've learned about what, you know, the model and the resistance that you're getting from the people that you associate with. So we'd like you to come on, and hopefully you just got the wrong day this week.
Okay.
Yeah,
I hope that's all that happened. And apologize to anyone who was watching, who was expecting Event Skeptic to be on, because we were too, but we carried on without him, and we invite him to come on next week instead. So tune in next Saturday at 5 p.m. Eastern Standard Time, and we'll let you know how the new curvature calculation panned out in the Flat Earth community.
Yeah, see you next week.
Until then, good night, everybody.
Good night.